Good evening, y'all. Welcome back to some more nerdery. Hopefully no fire tonight, Cookie, although I know you're always rooting for it. I never am. But we'll just see how this goes. I hope you enjoyed the fancy countdown. I had certainly a good time putting it together. I also spent a good while figuring out why it wasn't keeping time very well, because I thought it was very clever. I was like, oh, I'll set it for like an hour, and then I can start it an hour ahead of time, and then I don't have to worry about it. And I came back about 6 minutes ago, and it was like, oh, you're not starting for like another 10 minutes. It's like, oh, well, beans. So I fixed that a little bit, enough for this to have worked out, I think. Yeah, it's been a week, y'all, but I'm excited to be here with y'all good nerds on Sunday night. I see Cookie's here tonight, Thomas P. and Dave, good to see you. Burt Worthby Arms, welcome back, good to see you. NTP would be maybe a step where I just set the time back to lower and shortened my loop a little bit, and then hit the reset button at the appropriate time. Let's see, Nate's here, good to see you, Nate. Had an Arduino voltage regulator release the magic smoke. Ooh, yeah, so I am tempting fate just a little bit here. Let me take you to the table. So right now, just for testing purposes, there we go. I've just plugged into a little, Arduino Pro Mini over here on the desk, and it's definitely one of the janky ones that was giving us trouble the other night. But I've convinced it to work appropriately for us for this evening. But these little tiny Pro Minis, they're great because they're cheap. Like I get them for like $1 in quantity from the slow boat from China, but they are the main problem I have with them is their voltage regulators are even more underpowered than the Pro Minis should be. So if you're trying to use them for anything that draws any kind of significant amount of power, and I have not measured how much current I'm drawing on these little screens, but I am using the Pro Mini to power. I guess it's coming 5 volts out from the programmer into the Mini. So the Mini's regulator isn't actually doing any work to make that 5 volts. But that's the component I would be most worried about. I have smoked lots and lots of these little things just doing boring things like, powering some LEDs or something like that. Like they tend to burn out pretty quickly. Yeah, 12 volts, says Thomas. Yeah, same night, had a 1 amp constant current driver. Ooh, 1.6 volt or 1.6 amps is more than 1 amp. That seems like a bad a bad sign. Yeah, so like I know that nominally these little guys have a voltage rating up to like 12 volts or something, but I've never had good luck relying on them to do any significant amount of current draw. In this situation where it's actually, so these little OLEDs, which is what we're going to talk about this evening, I don't have a strong plan. We're getting 5 volts in from the USB line via the FTDI breakout board into the Arduino. That just goes out to the power rail, that goes into the display, and then this has a little boost converter in it to provide the higher voltage that the OLED screen needs to drive it, but there's a configuration option where it has a boost regulator just built in, so it will just generate that higher voltage for you, and it'll run on anything from 3.3 to 5 volts, so you can use a 3.3 volt Arduino, you can use a 5 volt Arduino, or other microprocessor, you can use Raspberry Pi, whatever you feel like to drive these little things. Aren't these things, I've been meaning to say this, aren't these things adorable? Aren't these things just like stupid cute? I don't know, I've got my camera kind of as close as I can rely on the autofocus to still work, but isn't that just the cutest thing I have here? Hang on. I have one of these here that I haven't put on the board. I've got a pack of 2 from Amazon because they were cheaper there than other suppliers. I mean, you can get them certainly on AliExpress for like $1.20 a piece, but this was the faster option. I mean, look at that. How small and adorable. They're 64 pixels across by 32 pixels high, and they come in like a couple colors. There's like I think this is nominally the white color, and there's like a pale cyan blue kind of color that's also available out there. Yeah, so let me back up. I tease this, or at least mention it. Thomas says you put them in everything. Oh yeah, so this is what I'm excited about. What I had been thinking of, and I've a little bit shot myself in the foot for this part, because like I say, I have this overhead camera, as close to the table as it can be, which is going to make showing off. Well, maybe I can still show off a few other things. Yeah, there we go. So this was a part that I got because I had been imagining doing this micro RDM control project, and it's still sort of a loose spec, but the idea was, we're making little tiny DMX controlled moving lights, which you all are sick to death of me talking about, but there's not a great place on here for any configuration controls, like on a full-size moving light, right? Like a Viper or a Mac product or what have you. You'd have at least a little tiny, usually like an LCD screen, and like maybe four buttons and an enter button, and you could use that to do some basic configuration, like set the address and the personality and so on. And on something this small, I just didn't ever figure that there would be like room for that. So the way my brain was going after all was like, what if we use, as some of you who've been following this project for a while know, we've gone through a few different revisions of how we might actually do something useful, like set a DMX address on these. And where my head has been is in the RDM protocol, the Remote Device Management Protocol, which is meant for doing things like addressing lights over an existing DMX link. And so implementing an RDM device library in the control boards that are driving the tiny moving lights, and then implementing, right, so getting ahead of myself, implementing an RDM device library in the tiny moving lights, and then because that sort of moves the problem back a step. Most people, myself included until very recently, don't have like an RDM node in their homes, right? Like when I think of the RDM nodes I'm used to, it's like an ETC Net3 node, which is like $1,000, maybe like 600 if you buy them in any kind of quantity. And that seems like a lot for the whole goal of this product is to be like cheap and cheerful and like easy to work with. So since I'm implementing RDM things anyway, I was like, well, let's take an even bigger bite off the apple. Let's see if we can implement an RDM configuration device in a little cheap pocket-sized form factor. And I found this is what got me excited about this idea. These are just a product from AliExpress, which are meant to take a couple of D-shaped like rack mount style connectors on either end, so you can build your own adapters with them, right? So if you had a 3-pin and a 5-pin XLR, you could make a 5-to-3 adapter. You make it a turnaround. You could put PowerCon or True 1 or 1/8 inch or 1/4 inch. Like they just sell you this box and you put your own connectors on it, right? Let's see. Broke both my arms says I've done some work with the 0.96 SSDs. Yeah, so that's what I was originally inspired by. Was like, okay, so I have this little form factor. I can put a 5-pin XLR output on one side. I can probably squeeze a little circuit board in here to do something. I mean, these control boards for the moving lights are tiny. Of course, they're all in things now because I keep building the lights, which is a good problem to have. So I can squeeze the control board in here, but then what am I going to do for a user interface? And what I had been thinking, which I was sort of waving about here in front of the camera for a few minutes, is like a little 3-digit 7-segment display. This is actually, so these are some cheapy ones I got from Amazon just for playing around with. There are some on both AliExpress and LCSC that are even smaller as a digit size. And I was like, okay, well this seems plausible. Like I can squeeze this in here somehow. And then I found these little OLEDs, and just the display possibilities for these are they're so much more powerful and they're so much cooler. So here, I won't bother taking you over to the computer to show you, but like just running a little piece of demo code on them. Let's see, which was my demo? I think it was this. We'll just run that. Because, it's been time to start here for a few minutes now. Uploading? Thinking about it. Not uploading? Not uploading at all. Here, let's do what I usually do and unplug the serial converter there and reattach it, and that usually gets the Arduino IDE to play nice and upload. Sometimes it loses track of its COM port that the serial adapter is on, and I'm not entirely sure why. But as soon as that uploads, it should do a fun, it's like, well, that's a little display, and it can show numbers, and it can count, and it could have, my idea is that it would have 2 buttons here for control, but we'll get into that tonight, because that's going to be, I think, the project that I actually get some work done on tonight with y'all here, and would love your input and feedback on, as always, is working on a little bit of the UI, the user interface for our PocketRDM is what I think I'm settling on the name of it as, the PocketRDM system, and that might change, but that'll be fun. But yeah, so I mean, really, just like how exciting is that? So to get these things working, so I should say the first part tonight, I have some updates for y'all that I'm excited to share, show off some things, and if you have questions, of course, as always, put them in the chat or call me call me on the big red phone. The number is on the screen there. It always cracks me up. It's an actual rotary phone that you can call and will ring quite loudly. I am told. And we'll see how that goes. But one of the things I wanted to share with you was what it took to get this OLED working, because it's not, there was a change I needed to make that was non-obvious in its behavior, just working with the Adafruit libraries for it, and I wanted to share that with you all because this seems like the kind of like cheapy, nerdy display product that some of you out there in the world might also use. So let me go through that real quick. And to show that off, what I think I'm going to do is re-upload here I'll show you, the test code from Adafruit that I was using to sort of diagnose the problems on this thing, which I'll upload briefly with my fix in place, and then I'm actually going to break my code again. I'm going to take my fix out just quickly here and show you what it was doing and how we fixed it. In case your particular display is not exactly like mine, and I don't really have any reason to think it would be exactly like mine, I can show you how we sort of got to our fix. So this is what the code from Adafruit is supposed to look like. It runs basically a variety of graphics demos, rectangles and lines and circles, and I think it does some text, does a filled-in circle. Rounded rectangles in various states of fill. What else we got here? Triangles. There we go. There's some text characters using the CP 437 character set. It has built-in like scrolling functionality, and so what you can see here is those speckles that it's scrolling over to are just areas of memory that don't have any data in them. Here's just a little bit of text. Here's it showing you it has a built-in invert function, and then it has the little Adafruit stars falling down the screen forever, or flowers, or whatever they're supposed to be. Snowflakes, maybe? So that's what it's supposed to look like. Let me, I think I've just done it. Let me re-upload this, and we'll see if it breaks the code. I think I've taken my fix out. I'll show you what it was looking like up until I figured out what was going on and how we diagnosed that. Because it was kind of an interesting thing. It's the kind of thing that, in the retrospect, I wish we had done on stream, because it was kind of a fun, like, hunt and solve problem-solving thing. I guess coding troubleshooting is not necessarily terribly visual, but it was fun. Let's see here if this will reset. Yeah, so this looks like, when I first turned the system on, I just ran the test code, this is what I was getting. And what you might be able to guess here, or what I think of this as, this is behaving as if all of these effects are meant to be centered on your display. And I have told it that my display is 64 pixels across by 32 pixels high. So it knows that it should be only displaying the amount of data. And actually that scrolling example there is really critical, because that means that all of the pixel data that I think I am sending to the screen, I am. Otherwise it wouldn't get that, that LL that wraps around to the bottom there at the end of the example, is showing me like, it's not that we're missing sending the data, it's just that it's not being displayed properly, right? And this data over here is a byproduct from when we were sending data to this part of memory previously. It's basically acting like the midpoint of the screen is here instead of here. Or in other words, it's displaying a different chunk of the memory than I think it should be. So really briefly, what these controllers, and this, as Broke Both Me Arms mentioned, this is another SSD 1306 is the name of this very popular control chip that a bunch of these run on. They are meant to, or I guess designed to drive a screen that is up to 128 pixels across by 64 pixels high. That's hidden behind my face there. By 64 pixels high, right? And I have a little tiny subset of it. I have a 64, I guess a quarter of it, 64 by 32 pixel screen, right? And this is how, the way I'm talking to the device now, this is what it should be displaying, but this, here, I'll use a different color, because I have a giant tub of colored Sharpies that I so rarely get to use. This is what it's showing, right? So when I do something like, draw some circles centered on the display, and it draws them correctly into memory. It draws them there, but I'm only getting the right-hand half of them here. Let me reset this. We can see a few of those graphics demos again. So does that sort of make sense, right? How it's displaying a different chunk of the screen than what I think it should. I don't know what it should be doing, as I guess is sort of a philosophical question, but in my mind, that's what would make more sense. But given that I can't really adjust that, and this all to say, maybe I could, maybe there is some configuration setting on the chip that would adjust this, but I haven't found it. I kind of just hacked it. So what I did is I said, so the commands, for writing text or pixels or lines or what have you to this display all essentially boil down to, do some calculations in the background and then put a chunk of pixels into this board's memory, right? So I have a buffer in the Arduino that references the bits, the 64 columns and the 32 lines here, and whether they should be black or white. And when I say, okay, now do some calculations and then make this pixel white, make this pixel black and this pixel white, and so on, right? Whether it's a line or a rectangle, right? It's all just calculations of whether a pixel should be black or white at the end of the day. And so what I did, it basically is put a line in the code, and I'll show you it in a second here, that says, okay, let's start a new diagram. If I want to write a pixel to the screen, and I will use a third color now, because again, giant bin of Sharpies, and I think I want to put, like, say, a dot here, right? But the display is showing me this chunk of memory, right? A 64 pixel wide chunk of memory starting at position 32, sort of offset a quarter of the way across the screen. Then really what I need to do is draw that pixel here, right? Every pixel that I'm drawing should be written to the screen offset by 32 pixels in the columns direction, in the X direction, I guess you could say. So I messed around with the configuration settings for this chip and things for a long, long time, and ultimately that's get to the root of the problem. Is like, let's just cut to the chase and just basically manually move all the pixels over by 32 positions. So in code, what that looks like, we'll open up VS Code here, is in the Adafruit library, and I am using the Adafruit SSD 1306 library here. I put in this structure in the display function. The display function is basically when you issue your commands to tell your Arduino to put some things on screen. You might draw a pixel, you might draw some lines, but when you've done all your calculations internally, you've loaded them all into a buffer, then you use the display function to actually send all of that data over the buffer, basically send your buffer to the display so it actually shows up. So right at the end of things, when I filled my internal buffer with a 62 by 32 array of data, I say, send it out to the screen using this display function. And here's what I modified. I said, if defined SSD 1306 6432, right, which is a flag that we're configuring in the top of its header file to specify the size of the screen, right? So it could be a 128 by 64, or 128 by 32, and so on, right? So if we're using this particular tiny Jeff Glass's desktop display thing, then rather than sending a 0 to start it off, we're going to send a 32, and that tells the device what column we're going to start with. So you can see out here, normally, if we're not in this case, we send a 0, and then we say what the ending column is, right, which is normally the number of columns minus 1. But in my case, I'm going to say, hey, start at column 32 and go 32 columns beyond where you normally would. And that sort of shifts the entirety of the display 32 pixels to the right, and that's what makes our code end up working properly. Anyway, I hope that was semi-clear and semi-interesting. Maybe not, but I was pretty, like I say, I messed around with, there's various ways you can configure this chip for the various sizes of LCD that it is designed for, and I monkeyed around with a bunch of those configuration options for 2 or 3 hours trying to figure out, okay, is it expecting them all to be sort of offset in one direction or not? Ultimately, I sort of just hacked in a manual shift to the right to make this work. There we go, and now we have the graphics demo, doing what it should. Everything's centered on the screen there. So there's that. Stand by. I should say, for some of you who care, I know not all of you do, but some of you do, tonight's beverage of choice is a Vienna-style lager from Dovetail Brewing Company. Dovetail does a lot of European-style beers. They're right down the street from us here in Chicago. Very tasty, very light, very drinkable, which is just great. So I'm enjoying that. If anyone's drinking anything super interesting out there tonight, as always, I love to know. As always, no pressure. If you are not drinking or drinking is not your thing, hydration would be a good choice. In fact, it probably would be a good choice for me as well. But if you are drinking something fun, let me know. Anyway, I might be done bragging about like the cool things that have happened with this OLED, but I might not be. I'm so delighted that these things work. It's very fun. Let's see here. I am just going to briefly open up a side page over here where you can't see it. Well, that's all right. You can look at my pretty face while I check on a couple of configuration things that are stream related. I know. Pay no attention to the me behind the camera. Oops. Let's see here. One thing that we've been aware of is like trying to, we've been reorganizing the network in our place just a little bit, or I have rather, and I just wanted to make sure, yes, I thought so. So I've not been seeing any chat updates for a while, but I'm seeing that there were some that I hadn't seen. So hang on, this is what I thought might be happening. So hang on, let me get all of your nice comments back into the world. Here, yes, here we go. Hi, people were sharing things. Live chat, you're here. Yes, Chris, I see you now. Very good, that's what I was worried about. Let's see. What have I missed? Phone has a volume adjustment. Oh yeah, so Chris, it has a volume adjustment. I just set the ringer all the way to quiet. So that'll be fun. Oh, the beer, yes, people were asking about the beer. I couldn't even see it, but now I can. Hello, we're back. Chris is having an Amber Soul Black Rye IPA. Ooh, that sounds good. And a classic Bud for Dave. You know, there's many times when like a PBR, like a Pabst Blue Ribbon, it's just like, it's cold, it's not pretentious, it's not fancy. Hop water, we call it. Just like a nice, refreshing beer at the end of the day. There's nothing so wrong with that. Well, good. Well, I'm glad that the chat, I was like, oh, I guess no one has anything to say about the display, which is fine, no pressure. But I was worried because often people have opinions about things, especially as they're getting fixed around here. So let's see here. What else did I want to talk about tonight? I made a little cheat sheet because I have no plan for this evening, but I had some thoughts. Oh, yes. So, let's see. So let me re-upload some code there. So one of the things that I've been thinking about is like how to use these little tiny displays to create a user interface for the microcontroller, I mean, my working title for it was the microcontroller, which is an awful name because a microcontroller is the thing, right? PocketRDM is what I'm thinking about. And so this is kind of the UI that I'm leaning towards, which is a sort of a primary display up top, which might be a DMX address or a personality number or something else, and then two smaller indicators down at the bottom in general for two buttons. That would tell you what the two buttons on the display do. That's gonna be a little bit experimental, and I want to sort of play with that later tonight as we start to develop the UI for this thing. He says PocketRDM sounds good. Yeah, it's got a nice ring. It doesn't exist yet on the internet. Like there isn't a thing called the PocketRDM, which is nice. You know, things like Micro Light and Mini Light and Pocket DMX and things are a lot, but RDM is a small enough category of things that it doesn't seem to mean anything else yet. So that I think is what we're going with. Well, good. Well, that's a fun thing. But yeah, so like this is kind of what I'm leaning towards. Modulo, like actually testing it in the field. The one other option I've been thinking about is, there we go. I'm not entirely sold on the like black on white lettering here versus white on black. But that might just be a usability thing once the device is actually like built. Like, is that clearer or not when I'm holding this thing in a catwalk 40 feet in the air to have it inverted or not? I think that's just like a UI test. And frankly, like that's a very easy thing to change. Because it's all going to be sort of programmable after the fact. And before we get into like looking at how that is actually programmed and working with it, let me show you just for more context what the PocketRDM boards currently look like. And pull that up here. I don't know if you can see the Eagle control menu there. It still says microcontrol in the Eagle project name, but it, of course, you know, microcontrol is a thing. I'm leaving that behind. So here is the idea. Here's the design in Eagle. Let's just look at just the top layer. That might clear things up. So the display and control unit on this thing would actually have 3 different circuit boards. But thankfully with mouse bytes, which we'll look in a little bit, I can fabricate them all as one big circuit board and then break them apart at these holes into 3 separate boards, and that saves on fabrication cost. So there's a board that will, let me grab some props again. There is a board that will sit flush on the top surface of this case here and screw into it just like one of these D-shape XLR jacks will. So it'll take a couple of the standard screws and it'll screw right in, and it will be an FR4, a fiberglass faceplate that will form the front cover of the display. In fact, here, let's look at that first. So that's this module, right? So it says PocketRDM version 0.3 because I love I love 0 dot version numbers. Apparently, the Demilight is now going to be in version 0.9.5. So I don't know if it'll ever get to version 1. Although Chris has been I know Chris has been poking about that, which is a good thing. Props for the win. Yeah, you gotta have props. Gotta have physical props. So this is the idea. So this shape here is the same shape as one of these D-shaped connectors, and it just has holes milled or drilled out for 2 buttons down at the bottom. I currently have them labeled A and B. I don't know if that's necessary, but this is just a prototype, so we'll see if that's a thing. And then it's got this hole cut out here so you could see the OLED display behind it. And then my current thought, and I'm not sold on this for sure, but at least just as like an easy thing to prototype with, I decided to put 2 of the standard like 100 mil header pins as my fastener between these 2 boards. I'd originally spec'd it with like M2 screws and so on, but again, just for a prototype, this seems easy enough. So we'll break 2 of these off and solder them through a couple of holes in the front board and the display board that we'll look at in a sec, and that's what's going to hold them together. That does mean there's little pokey bits come out the front, so that's like not a great long-term solution, but again, I mostly wanted something that would be easy to align as I'm working with this sort of nested PCB idea for the first time. So these will ultimately probably be, I mean, honestly, later on, this is probably just glued together, right? You probably just push one circuit board up behind the other and glue them together. But for now, that's what we've got. So behind that outer PCB, right? So behind that front one here, which has no electronics on it, you'll notice, right? There's, other than these 2 solder points, there's no reason this has to be a circuit board other than that's a really cheap and easy way to get it fabricated. Behind that sits a board which is a carrier for the OLED. So this is the footprint of one of these little adorable OLED modules. Just 4 pins, ground, VCC, and it's an I2C product, so it takes clock and data. Right, it's got 4 pins to plug in and solder that in, and it's going to have 2 surface mount buttons on the front here. I didn't think to do this in advance, and I hope I'm not overtaxing the computer. But I did a 3D render of an earlier draft of this that I might still be able to show you. I haven't checked this in a while. This will be the version that has the 7-segment display, but I think I did some nice 3D modeling of the buttons just to, yeah, so here's the idea. Where's my, do I have an orbit? I'm not very proficient in KiCad, I will entirely admit. So forgive me for my lack of ability in navigating. Oh, it's running away. Come back. There we go. So this would be an example of something like what that control board looks like. This obviously is a slightly earlier version, which has this, like I said, a giant chunky 7-segment display, but we have 2 of these surface mount sort of tall plunger buttons that would protrude through that front PCB to be our 2 sort of control buttons for this thing. These are each a 6mm by 6mm footprint, and I think these plungers are 9mm. They just stick out, I think, like 1.6mm through the front plate. Just they're a little bit proud. You can press them affirmatively, but they're not bumping into anything in your pocket. Kevin has a question. Kevin says, will it charge through the XLR plug? Okay. Well, we'll get to charging. That's going to be a next step. The short answer is no, but how does it charge? Also a good question. That would be very fancy. So I guess it could. I had never thought of that as an option. So what would that mean for us? My only worry there, so this is a 5-pin XLR female for DMX and RDM output. So we could make if it had a rechargeable battery, right? If it has a chargeable LiPo in it, maybe we put a charger on here that connects to pins 4 and 5, and that's what. Because what I would hate is this thing's now got a handheld device, or a charging device that has, let's say 4.2 volts on it, with an XLR male connector on it that's just begging to be plugged into the wrong thing and frying it, and I don't love that. But maybe. I have a couple different thoughts on batteries, but let me go through the summary of this. And I'll tell you what I'm musing on there. Like I said, I will still take any suggestions that people might have. Charging through the XLR port is something that would never have occurred to me, so thank you. And maybe that's a clean way to go, because I'm really trying to focus all of the connectors and manipulability onto the ends of these things, so I don't have to monkey around with machining the case at all. But you've come to a crux of a problem. Here, let me close up KiCad here. And come back to Ego. Yeah, so this is our control board, right? It's got the screen, it's got the 2 buttons, and then on the back, it's just some connectors for. This is an old version, I'm pretty sure, because I hope I did. I think I cleaned up this labeling in the production version. It looks like this says button 2 on all these. It looks like it says butts from this perspective, which is kind of funny. But we've got a ground pin, 5 volts, SCL, SCA, and then 2 pads for button 1 and button 2, and those buttons are just bridged between their respective pads and ground. So you put a pull-up on them at the controller side, and when they're pulled to ground, the button's pressed, right? So you do that all the manipulation on the controller side, and then it's got a little bypass cap here just right next to the display, just for good measure, right? So nothing terribly fancy going on there. And then the third board is the part that I have done the least on so far, just because I feel like there's more steps to validate in the controller beforehand. So just for the sake of getting something out to fab, I slapped an ATmega 32.8 footprint on here and a Max 485 footprint on here. That's our RS485 transceiver chip. I threw some various options for placements of wire headers here. These would be the headers that connect to the solder pins on the back of the XLR5 connector. So exactly what the positioning of them is, I wasn't sure, so I just threw some options in there and a through-hole header for connecting to the display. I should say I'm ordering these entirely unpopulated, right? They're just circuit boards. And because I was ordering a batch of the Demilight boards anyway, these came out, I think I bought 10 of these boards, so 10 sets of 3 for $5. And I'm paying, it's the same DHL shipping because I'm getting them along with the Demilight board. So it's basically free. So I wanted to sort of get a revision done, test the faceplate, test the idea of this display and these buttons, and then I'll start worrying about how to make this control board work. So that's sort of where that's at. You see, I put the labeling on here. It's going to be 36 by 22 millimeters because I'm a little bit unsure exactly how much clearance is going to be appropriate to have in here. It's probably a little hard to see on camera, but you can put a circuit board. There's a fair amount of clearance underneath the solder pins under that XLR5 connector down there. But is that usable space? Is that useful space? So I just fabbed up what I thought was a reasonably sized board that would fit between the pins of the XLR5 and my 2 PCBs that'll live on this face. And we'll just see. It's basically just going to be a size check, and just to give me a real good example of oh, okay, well this can be a little bit longer in the length, but it can be a little bit shorter, a little bit narrower across the body of the thing. And we'll just get things going. So yeah, so battery power is a conundrum. And I have a few thoughts. Here's my thoughts on rechargeable for a number of reasons. Rechargeable would be fantastic, whether it's got a mini USB or it's got USB-C or something on it with a little LiPo inside. I am just a little bit nervous about putting me, the non-engineer, the maker, am a little bit nervous about putting LiPo batteries into things. And I know that especially lithium polymer batteries have gotten a lot safer in the past few years. But in contrast to the Demilight project, which currently, other than the fact that it makes some watts of heat, there's nothing you can really do that would be, catastrophic. Once we start talking about LiPo batteries, especially not in like the traditional 18650 form factor, we start to get into like a little bit of fire risk, and that makes me just a little bit nervous. But from a usability standpoint, that certainly would be the best thing, right? So, but it just makes me. I don't know if anyone out there has tried LiPo charging in their own solutions, and there are some good examples that we could steal from, right? Like Adafruit's Feather line of boards all have built-in LiPo charging. The SparkFun makes a board that does LiPo charging. Here, maybe we can pull those up and have a look at them, just because they're kind of interesting. Adafruit Feather. Here, I'll take you over the computer. Adafruit Feather 328p schematic. You can see I was looking into this previously. Adafruit Feather 328p. Let's look at their schematic here and see what we can steal from it. So like here, they have a LiPo charging circuit. One thing that is true about the Feathers, and I think about the SparkFun product as well, is they assume your processor is running at 3.3 volts. I'm trying to remember what this research was that it was true. Chris was going to do a product with a SparkFun charger and battery. Yeah, for sure. I mean, and then if I was going to do this, I would certainly be stealing from the best. Both the typical Adafruit Feather, it's not zooming. The Adafruit Feather design and the SparkFun design use one of these MCP parts. This one uses the 73831 charger. I think the SparkFun one is a slightly different part. But they do some clever things doing battery charging. They have a power filter here. So this is a circuit that would be worth stealing for sure, in the sense that if you plug in a USB cable to the Feather, it will charge the batteries off of the USB while it powers your device off of the USB, right? It will sort of interrupt the flow of battery power using this FET here, and then continue to use one of its power controllers to continue to, this is a 3.3 volt regulator that's driving the 3.3 volt line. And then what is VBus in this case? VBAT, VBus. Where is the junction between those two? What else connects to VBus? Here's our USB connector. Oh yeah, so VBus is what's coming right in on the USB cable. So if you plug in the USB cable and the voltage on the USB line is higher than the battery voltage, which in this case is meant to be just a single cell LiPo, right? So 3.7, 3.8-ish volts, it will interrupt the power flowing from the battery to your Arduinoid device, right? Your 328p in this case. And this regulator, this APA2112, will just put out 3.3 volts powered directly from USB. And at the same time, your charging circuit down here, your MCP 73831, is using that same USB voltage to charge your battery. And this is all well and good. One thing I got hung up on is, so per the RS485 spec, we could run I think our Max 485 off of 3.3 volts. In fact, let's double check that. Max 485 datasheet. I hope you folks come for the noodling, because that's mostly what I do. Let's see here. Max 485, electrical characteristics. This might be specifically supply voltage max 12 volts. So the maximum differential transmission voltage, or the minimum differential transmission voltage on RS485 is like plus or minus 2 volts of relative signal. I have lots of various options here for 3.3 volts. I'm just trying to remember if the Max 485 is specifically a 5 volt part. And I don't think it is. I just don't know if it has a minimum input voltage. It has a maximum supply voltage of 12 volts. I'm trying to remember if it'll run on 3.3, but Kevin's here for the noodling, or virtual Kevin. I guess Kevin may not be here, but Kevin's virtual self is here for the noodling, which is great. And Chris will take some spaghetti. Good. Well, then we've got lots of spaghetti for sure. So anyway, the whole point is both this schematic and the SparkFun one assume that your battery voltage is always higher than your system voltage, right? So you got a 3.7, 3.8 volt battery, you have a 5 volt line coming in from USB, you have a 3.3 volt system voltage, right? So all you need is a low dropout regulator of some kind. In this case, the AP2112, but there's lots of options in that field, right? As long as it can handle, regulating with a, regulating 3.7 volts down to 3.3 volts, like that's too low for a traditional linear regulator, but it is fine for a low dropout regulator like this. Here. Stand by 1 second, please. As those of you who've been here before know, questions at this time, and when I ask for questions, it's really just an excuse for me to wet my whistle a little bit, but I will always take questions. Stand by. Very tasty. And I remember to unmute myself, which is also a triumph. So if I want my system to run at 5 volts, I have a slightly different conundrum here, right? And there's that open question, like, does it have to run at 5 volts? But if I have a single cell LiPo, right now I have a 3.7 volt battery voltage and a 5 volt USB bus and a 5 volt system voltage. So I need a slightly different setup here, and then I either need a boost regulator, which is non-trivial, and then a pass-through, essentially, like if the, this would be something more like, well, no, it wouldn't either. I was gonna say it's like an Arduino Uno, but it's not. I need a boost regulator and a bypass FET, which I could do, but putting a boost regulator in this thing seems like seems unnecessary. So now we're looking at maybe 2 cells of LiPo battery, right? So we have our VBAT is now 7-ish volts, on our V bus, our USB input is 5 volts, but charging a 2-cell LiPo off, or 2 LiPo cells, I guess I should say, is significant. Excuse me very much. It's significantly more complicated than, or from what I understand, charging a single-cell LiPo. So there's lots of options here, and I'm not quite sure what to do about them. So this, I should say, this is my first time thinking about putting the charging solutions for a LiPo product into a project of mine. I have done projects with like 18650s built into them before, which are, I should have pulled one earlier. I don't know where I would even pull one from, but a standard chonky, looks like a giant AA battery here. If you haven't seen an 18650, Google, it will be our friend. They have become sort of the de facto form factor for removable lithium polymer batteries, big chunky ones. And there are other form factors of this as well. 18650 is just the most common. 18650 referring to the fact that it is 18 millimeters wide and 65 millimeters long. There are, like I say, other form factors. There's, I think, the 22650. Yeah, which is the same thing, but it's 22 millimeters across and therefore has more current capability and more capacity. And there are some smaller ones, which I don't know off the top of my head. If I search for 18650 but smaller, let's see. A8. So this is the other thing, is now there's all these like lithium non-rechargeable like primary cells. What do we got here? This is a 16340, right? So 16 millimeters across, 340 millimeters, 34 millimeters long. And that kind of form factor would be neat for something like this, right? Like it would be small, it probably would fit right in here, and then I could, but then you need a charger for a 16340 battery, which are not super common. Yeah, I don't, here, let's take some measurements and see. I don't think just eyeballing this in 18650 will fit, but we'll get the calipers here. So I'm just gonna depth to, well, here, remind me what the overall length this thing is here. Put it in millimeters, zoom out. This whole case, the whole case is 65 millimeters long. So it would be end to end if there wasn't an XLR connector and there wasn't a PCB. I don't think there are like longer, so one of the things that's attractive about this, there are other form factors much like this available in metal. That are significantly more expensive and just a little bit larger. So like if this was a little bit larger and could accommodate an 18650, that would be great, but it starts to get into like a a more customized part, which I'm trying to avoid. So, and maybe this is not the right option. Maybe going with a more customized enclosure would be the thing. But for this particular case, 18650 just doesn't quite fit. Another option, so what do we got? So we've got single cell LiPo and the 3.3 volt or 5 volt question associated with that. We have 2 cell LiPo, which now has a regular voltage regulator instead of a boost regulator, but now we have to charge 2 different LiPo cells, and that's a problem. 18650 doesn't fit, at least in this case, right? Like maybe it fits in a different one. We have the smaller LiPo subsection, right? We have these, 16340s and the other various sizes of small LiPo, which would fit, but now we have to sort of deal with, can you get just like a 16340 charger? Well, you certainly, I guess you can. Oh, and maybe some of these universal chargers. So this is kind of what we would use back when I was working at a job that used a lot of 18650 batteries. We would have one of these spring-loaded chargers. That's not an awful solution, because a bunch of these standard ones have that sort of spring-loaded clip, and so probably would fit them. So maybe it's, you get one of these, it's got a 16340 inside it, and in the box is a little, single-cell charger that just says, pop the thing out, pop one of the ends off. It's probably the XLR one. You say, if you think it's running out of battery, undo the 2 screws, pull the board out, pop the battery out, put it in the charger for a couple hours, put it back in. Coin cell, yeah, Virtual Kevin, yeah. So coin cell is an option, rechargeable or not. Just for size factor here. In fact, I have a variety of coin cells we could play with just to get an idea of size. Here, what can you hear? You can look at my nice messy workbench here, counting up to infinity as I go retrieve it. So as those of you who have been here before know, the storage for a lot of these parts is up and above and sort of behind the workbench and the camera. So if I don't leave you just showing the tabletop here, you get some tummy cam. And actually, where I'm having to climb up to the top shelf here, we'd be getting intimate in a way that is not really my purpose on this channel. But having retrieved that big box of batteries here and putting the stepladder back aside, we can get into what's going on here. Hello, we're back. It's like I never left. Chris's crank generator. Yeah, you could just, hey, I need to address some lights. Oh, hang on one second. Ricky. That'd be fun. So I just pulled, it's a little hard to see now because we're zoomed way in. Pulled just like a bunch of I pulled my battery bin out of storage. So here's a CR2032, which is, I don't think rechargeable. They're lithium, so they're lithium and they're 3 volts. It's kind of an interesting thought. Oh, yeah, and this might be a fun thing to play with. This is a dual cell 2032 battery pack that I bought a few of to play with a few years ago. These are, and I don't know, oh yeah, well here, tummy cam, here's what I got them for. Getting out my box O multimeters and stuff. Yeah. So the reason these dual 2032 packs are neat is then you have 6 volts in a little tiny form factor. Not a lot of capacity, right? But you could do things like, and this is bodged together with sticky tack, but that is a full voltmeter in a little tiny package, right? So it's got 2 2032 cells in there, a little 7-segment voltmeter display. You can buy these on Amazon or on AliExpress or wherever, and then that just becomes like a slap-on voltmeter. Here, let's plug something in that we could see what it's doing. Let's see, probably don't plug that in. Let's plug into the wires on our breadboard here. There's power, and there's ground, and now in theory, if I haven't broken anything, there we go. So currently this thing sits about 6 volts. That doesn't seem great. It's sort of a bad sign. But in theory, you have a little like handheld, portable, stick it somewhere, work with it voltmeter you could do a thing with. I wonder if I've messed up the wiring and it's reading its own voltage, because those two LiPo batteries are each 3 volts or so. Should take a look at that. I don't remember it being messed up, but I don't remember a lot of things. Brookbo says there's those small LiPos with JST connectors. Yeah, so like we could do like a hobby style LiPo for sure. We could do like, oh, I moved my keyboard out of the way. This was a huge life upgrade a few weeks ago that I won't mention about, right? So as so many of us are, I imagine, like, so I am working out of my home workshop for so much these days, and we're all home a lot these days. Going to a wireless keyboard and mouse, even a cheapy like Logitech one, has been such a huge difference, because now I can sit here, I can do my computer work, I can stream, I can talk to you, and then it's like, oh, I want to spread out and work on tiny moving lights. Pick it up, move it to the corner, doesn't worry about it. It frees up a lot of cabling and wiring. Ditto with like a cheapy, I think it was a $6 wireless mouse. Totally worth it. If I said wireless mouse earlier, I meant wireless keyboard, Chris. I apologize. But yeah, that has been a game changer. Just because like this 4 foot by 8 foot table, it's not even that. It's like a 3 foot by 6 foot table. This is my workshop for now. What were we? Oh, miniature lipos, says Broke Both. Yeah, so we could do, just go to Amazon. Could do something like these little guys, right? Like, and they come in all kinds of different brands and sizes and capacities. And now here's a thing I don't know, because a lot of these have a little tiny BMS built in. You would still need a charging circuit for them of some kind, I imagine. Because I think the charging for them is not just like apply DC voltage and allow to charge. So we could do like a 2-cell one of those. But size again becomes a little bit of an issue. It's hard to get them really as small as I would want. Let's see, what's the dimensions on something like this? 1000 milliamp hours, 3.7 volt lithium rechargeable. What's some dimensions on this? This is just a random like listing I pulled up on Amazon, but this is often how, I mean, hey, you said you were here for the noodling. Just like thinking about like what the space of possibilities look like. This is kind of a fun thing to do, is like, okay, what, pull up products, are we in the right ballpark, right? Oh, if this is going to be too huge or too small, we'll forget about it. This is 8.5 by 25 by 40 millimeters. So what's our working space here? I had started to think about this at this point, but I can't remember any of the measurements. So in here total, we have about 25 millimeters by about 20 millimeters by about, to the XLR connector, about 50 millimeters. So 20 by 25 by 50 is the entirety of the space, and we're going to lose maybe 10 millimeters at this end for the two PCBs that form the end cap, and I don't know, maybe, this is partly why I fabbed that test PCB, maybe 5 millimeters. So we have like a 20 by 20 by 40 space for batteries max in here. Let's see, Brookboth says there's external chargers for those batteries, but usable if you make the battery removable. Yeah, it's not a bad idea. I mean, anything that frees me of like the worry that I'm going to sell or give somebody one of these things and their house is going to catch on fire, I am all about. That's kind of why the little like 16340s are a little bit tempting. I mean, it's bad user design, but it's good designer sleep, I think. What does a smartwatch use? I don't know. I want to say they use little miniature lipos. Should we Google it? Should we find out? I feel like iFixit did an Apple Watch teardown, or let's see, iFixit Apple smartwatch, Apple Watch Series 6 teardown. Let's learn this together. iFixit, a super cool site. If you're, I mean, this is actual engineering. What I do is like bodgling about with parts, which is what I want to do. I'm having a great time as always. But let's see, this is a 44 millimeter watch cell rated at 1.17 watt hours. Smaller. 40 millimeter Series 6 is a radical metal pouch design referenced in the Series 5. So they use little tiny lithium ion batteries, little watch cells. That's interesting. Can you buy those? Let's see. Oh, hey, Alex B. Have me on the couch to stream it. Well, welcome to the stream. We're noodling, as we've decided tonight. We're noodling about little tiny OLED displays, and specifically how we might put battery power into an RDM configuration device that lives in this little like 65 millimeter package. And who asked? Virtual Kevin asked us, what does like a smartwatch run on? And at least Apple's runs on a lithium-ion battery, little tiny watch cell. So like one of these. So now we're just going further and further down the rabbit hole. Like, what could we use for battery power for these things? What are the dimensions here? I want specifications. Well, the model number on this is 402040. So I will bet 402040. That doesn't make a lot of sense. Sometimes the model number gives you a clue to the dimensions, but that doesn't make a ton. I mean, unless it's 40 by 20 by 4, that could be what it is. That would fit. 300 milliamp hours. That would certainly fit. So one of the obvious concern. Oh, you can't. Yeah, I've been looking at the wrong thing. It's just AliExpress. You've all seen AliExpress before, and if you hadn't, and maybe that's too broad of an assumption. Because I ran into some with some nerd friends on one of a text chain that we had the other day. Sent me like a weird product listing they found on like a meme on Facebook or something. I was like, oh, you want weird things? Here's AliExpress. And they're like, what's AliExpress? AliExpress is the consumer arm of Alibaba, a giant Chinese vendor. They have all kinds of things on here. And especially if you're willing to wait weeks or months for it, it is radically cheap. How good is quality control? What a good question. So this is a 402040 model, so it's probably 40 millimeters by 20 millimeters by 4 millimeters. It doesn't look like it has any protection. Like these wires are probably just soldered to the cells, which is less than ideal. But I wonder if we search something, now that we know some search terms, we're going to say 402040, see if anything interesting comes up that's a relatively standard size. And it looks like it is. 402040, 350 milliamp hour lithium polymer rechargeable battery for DIY tablet and such. Huh, interesting. Wonder if we can get some on Amazon. Let's see, 402040. You sure can. You can get this one. You can get it. I could have it on Tuesday because we live in the future. Rechargeable lithium ion. Oh, and this one has like an actual BMS on it. So this is like, what I am trying to avoid is a product that is just a lithium battery with 2 leads soldered to it that you have to do all the pack management yourself, because again, a little bit afraid of lipo fires. But if we could find one that was like this, that looks like it has a little battery management built in, right? We're still in the world of, what do we do about do we run at 5 volts and have a boost converter with a single cell, or a regular voltage regulator with 2 cells? Still some questions there. How do we manage charging on something like this? How are you? Who was suggesting this earlier? Oh, Broke Both. There are external chargers for this, but usable to make the battery removable. So yeah, so like, what are you meant to use to charge a LiPo like this? And I swear, as always, we've wandered far afield. We will come back to what, in theory, what I was working on tonight, which is like the UI for this RDM device. But now we're down this battery rabbit hole. I'm not sad about it, because this is a key sort of design and functionality question. Oh, Thomas says when you discovered AliExpress, that was a time. Yeah, it is a rabbit hole. AliExpress. A great place to shop. Banggood, more for consumer goods, but a fun place if you're looking for like tools. BAN. It's not. People have weird things about this name. It's not anything particularly dirty or malicious. It's just like, bang, you got a good deal. I don't think it translates very well, but if you're looking for drones or 3D printers or like cheapy smartwatches or little flying things, right? The AliExpress is where I would go to buy batteries and headers and knockoff Arduinos. This is where I would buy, a pancake 3D printer. Let's see, is that what this is? Oh, it's a little mini CD router. It's not a pancake at all. It's just some wood, but I think a pancake would be more fun there. A super fun place to shop. Oh, and GearBest, says Alex B. Yeah, GearBest is another place for like super cheap consumer gear. And some decent ones too, but like I go to them when I'm like, I want the cheapest version of a thing. They look like kind of like Harbor Freight. In fact, I think a lot of Harbor Freight stuff comes from a similar factory. So coin cells is interesting. What do you suppose the capacity is? Did I put my batteries away? No. Wonder what the current capacity is on a standard 2032. I don't know. Coin cells are kind of an interesting option because they're everywhere, right? Whether they're rechargeable or not. What are these? I have a CR. So these are 2016s, so they're a half the width and still 3 volts. I don't think these are rechargeable. I was just looking to see if they had any information on current capacity on them. Do not place in fire, do not swallow. No, of course they don't, because they're not meant to be sort of spec'd into projects like this. I wonder, CR 2032 current capacity. Thomas says, would a AAA battery fit? Interesting. Interesting. Let's see if I have double A's in here. Oh, hey, I have 18650s in here. That's where I'd pull them from. But yeah, I think it's gonna, yeah, so like, they're exactly the size of the case. That's funny. Let's see. Oh, Alex, what are we using for control? So, I chatted about this just a little bit ago, but the gist of it is we're fabricating a PCB, which is Arduino based for sure. It's basically going to be a little Pro Mini. That is, so the idea is we cap one end of that control tube with a PCB that sits flush on the face and it's just a display. There's a little PCB behind that that fits the tiny control and a couple of buttons. And then this is, of course, not finished yet. This is just sort of for my size reference. We'll fab a little PCB that has an ATmega 32.8, a Max 485 for the DMX and RDM sort of in and out. That's our RS485 transceiver. And then I just slapped some headers on it just to like get a sense of size. It'll be pretty similar to the Demilight control board. In fact, I'm going to steal a bunch of the circuitry from it, which if you haven't been to a stream before, you may or may not have seen. So this is quite dense, but what's nice is like the Demilight has a lot of room taken up with this whole part of the circuit board. Here is the LED dimming circuit, right? Then we lose a bunch of room, and by say a bunch of room, this whole thing is 35 by 36 millimeters, right? So the size is an issue regardless. We lose a bunch of space to the LED dimmer. We lose a bunch of space to the connectors, the 0.1-inch headers for the LED and the servo motor connections. There's a big space left down here for a buck regulator to get us 5 volts to drive the processor. And then we have a bunch of passives associated to a couple of LEDs. We have the crystal down here for the driver. We have a big fat input-output connector because we've been using, which I still love. Palmer, I don't know if you're with us tonight, but I love the Phoenix connectors. We have a big chonky Phoenix connector that goes into them. Here, maybe I can steal this board. So that becomes this board. So of this board, right, we're gonna essentially steal this is the board that I designed that I'm gonna steal for myself. I'm gonna steal, the layout for the ATmega 32.8, the Max 485, the control crystal, and some kind of programming header. But that should all fit on a relatively small control board. So, just for like a sense of scale, right? So we'll have, there's our controller, our Max 485, and some passive components. And again, this was just, I wanted to just get this out because I was putting in an order for the Demilight boards assembled. So I just splurped this out so I would have something to play with. So Arduino base, it'll have the Arduino bootloader on it even because that's the easiest way for me to develop. And we'll go from there. That's a really rough answer as to what the control system is, Alex B, but I hope that makes a little sense. Thomas says nominal capacity on a 2032 is 210 milliamp hours. Okay, so not awful. Continuous discharge at 20C under 15 kilo ohm load on 2 volt end voltage, sure. 235 milliamp hours for a 2032. Okay, yeah, so like a little over 200 milliamp hours, which is not crazy. So one part of this, of course, is as a battery-powered device, and this may or may not be part of the UI that we work on tonight, is, so coming back to our little tiny screen that we started this all with, in principle, the idea, and it's not entirely well fleshed out by yours truly, but, you'd carry the device around in your pocket and you'd be like, oh, hey, will you go up and address those lights or check the addresses on them or change the personality? You go, sure. And you grab your little device and you're up to the catwalk and you turn it on, probably by pressing either button that causes it to boot up. You plug it in, you do your thing with it, you configure devices, and then after X number of seconds of no activity, maybe it's 30 seconds, maybe it's 20 seconds, the device goes back into deep sleep, right? And there are some deep sleep modes on the 32.8 that are really significantly low power. I think the datasheet has estimates for that. Let's see if that's true. H32.8's data sheet. Let's see here. What I want is low power modes. I only want electrical characteristics. If I can't find this too quickly, I will punt. But let's see, DC characteristics. DC characteristics. I thought it had. Oh, here we go. Yes. So various power down modes. Let's see. So I guess one of the nice things is that running at a lower voltage, right? If we ran this thing at 3.3 volts on like an 8 megahertz timer, maybe we need to also consider lowering clock speed. Huh. Yeah, low power is going to be a thing that really drives us here. Oh, Thomas, you'd asked about AAAs. Just trying to think if I have any close to hand. Let's see. Yes, all various advice on minimizing power consumption. Power supply current, power down mode. So yes, we'll disable any accessories that we don't need. We'll disable extraneous timers. If we had ourselves running in 3 volt mode with no watchdog timer, and I think we don't need one. Let me check chapter 9 of the. See, now we're deep into noodle territory, but I want to see. Let's see if I go into the deepest sleep mode with no watchdog timer, then I can boot from standby mode is just the watchdog timer, TWI address watch, interrupt 0 pin change. Ah, okay, so if I put my 2 buttons on my interrupt pins, I could wake from that in standby, which I think standby is the lowest power mode. Let's see, power down mode, power save mode, standby mode. Standby mode is identical to power down with the exception that the oscillator is kept running. Ah, that's not what I want. I want power down mode. External oscillator is stopped while the external interrupts, the 2-wire serial interface, and the watchdog timer continue operating. Only an external reset, a watchdog interrupt, a brownout reset, a I2C match, an external interrupt, or a pin change interrupt can wake it up. Basically halts all generated clocks, allowing operation of asynchronous modules only. That's what I want. I want the thing to be as deep a sleep as possible. And this is all to avoid, like, one option would be put a power switch on the thing, right? We could have a little button or switch or something that like is literally power on and off. But I think it's a little bit cleaner if we can just have this thing sort of go to sleep, wake up, and put itself back to sleep. I don't know about you, but I am awful about remembering to switch these devices off. Like if my multimeters didn't have auto shutdown mode, they would all have dead batteries all the time. So I like the idea that it just puts itself to sleep. And conversely, that it just wakes up when you press a button. Let's go back to our electrical characteristics here. So in our various power down modes, at 3 volts with the watchdog timer enabled, we draw 40 microamps, which is pretty good. So let's do a quick back of the envelope. So let's say we were running on a 2032 battery. 2032, which Thomas says has a nominal capacity of 210 milliamp hours. So we have 210 milliamp hours divided by, I know you can't see, well, here we can do this in the calculator. We can see a little better. 210, my 2 button on my wireless keyboard doesn't work. Do all the others work? No, some of them don't. 4 doesn't work. Well, that's unfortunate. Put 210 milliamp hours divided by, or 210 milliamp hours, yeah, divided by, this would be 44 milliamps, 44 microamps. Is 4,772 hours. I think I've done that right. divided by 24 hours in a day. So it was like 200 days, basically, of standby time, which is not great for a coin cell operated thing. Like, I don't want to be swapping out coin cells every 2 years, or like twice a year. That seems like too much. It could be 2 coin cells in parallel. That would give us a year a year of standby time, right? And so when this thing is operating, what's our power budget look like? When we're on, let's say we're running at 3 volts at, well, currently we're running everything at 16 megahertz, which we don't really need to be, but let's say we are. 16 megahertz at 5 volts, so we're drawing 2-ish milliamps. Let's say we turn off a bunch of things, 2-ish milliamps. So that's 100 hours with a single coin cell at, do we have a 3 volt option? At idle, and let's say we're not idle very much. Oh, if we're not idle, we're drawing closer to 10 milliamps. We have 20 hours of operating time or 200 days of standby time with a single coin cell. So that doesn't sound bad. The 20 hours of operating time, I think, is a fine goal. You know, thinking about like how often this thing might get used during a load-in or a changeover, right? Like that's, maybe it's an hour and a half, maybe 2 hours of use every load-in, that's fine. It's the standby time that I don't love. Like, if it's gonna be coin cells, especially, I don't wanna think of, if it doesn't have an external charging port, I don't wanna change the batteries in it more than once a year. I think that's a decent goal. And that's just thinking about like, you know, if I had, when I was a full-time theatrical professional, if I had, you know, if we had 15 load-ins in a year, and every 6th one, the batteries in the thing were dead because it was sitting in the cabinet and I had to change out 2 coin cells, it's kind of annoying. I'm gonna take a quick questions break and wet the whistle because we've been doing a lot of thinking, and thinking's thirsty work. Chris says quadruple A's in parallel. It could be. It's not a crazy idea. I was just looking around to see if I could think of anywhere that my battery bin doesn't have any triple A's in it. It just has. I have double A's. I have 18650s. This is. You know what I can do is text my wife and see if she'll bring me some triple A's. Me some AAA batteries. She's great. I don't know if you can see, she keeps writing notes to people up on the whiteboard behind me here since I haven't actually used this whiteboard for hardly anything since I put it up. She just writes notes there. Maybe if you have a really high resolution display, you can see it. Let's see, is that load at 5 volts because the battery's at 3? Oh, yeah, current draw would certainly be higher. Yeah. So this would be one, Thomas, that's a great catch. This would be one advantage to like running at a lower voltage is you have less current draw. So if we ran just at 3 volts native, at 4 megahertz, and I'm a little wary there only because some of the timing on getting the Arduino to recognize, excuse me, the break and the mark after break is a little kludgy, but in theory we could run on a slower clock. We'd have significant current savings there. Let's see. She liked my text message, so in theory she'll be showing up with triple A's in just a moment here. We can always call, yeah, we could call her on the bat phone if we wanted to. That would be appropriate. She likes Malort a lot more than I do, I will say. Hence the phone number. Oh, I hear some rustling. It's true you like Malort more than I do. Here, come say hi. Some of you have met her before. My wife, Mary.
Hi there.
Thank you.
What are we missing?
We're working on battery power for a little like pocket-sized RDM controller. We're using the little tiny screens that I got, and so I pulled out my battery bin, but I didn't have any AAA's in there.
Have fun.
Thank you. Thanks, hon. Everyone says hi. Hi. Thomas says hi, and Chris and Dave. She's the best. Tremendous. So, yeah, I'm a huge fan of my wife. I hope so. Let's see here. So, there's our case. AAA would fit. AAA might actually fit great. Let's grab, so I have a little bit of a, move the keyboard out of the way again. I have a little bit of a variety of AAA cases in here from previous adventures. Here's like a fairly slim one. Because I don't hate the idea of, like, you know, especially if it's got 2 or 3 years of, oh, that's not going to quite fit, huh? If it's got 2 or 3 years of standby time, I'm just saying, like, hey, if it's dead, it's a little bit involved. Like, take the XLR jack off, slide the circuit board out, replace 2 AAAs, put it all back together. Like, is that the best UI? No. Is it passable? I think so. I guess it'll sort of depend if we could find a battery holder that would fit inside this case. I guess one thing that will kind of have shot me in the foot here is... Oh. Yeah, so I'm running out of room a little bit because of that. The XLR jacks are just, like you can see in profile there, this is just another one from the same pack. Like they're very chunky because they have to accommodate the shell of the SLR. Oh, let's see, Alex says, could you use one of the little slide out battery things, but from the side? Like from the outside here, you're thinking? I certainly could. So you don't need a screwdriver. I guess I'm not. Oh, like one of those like battery, like on a remote control, like this kind of mechanism, like clicky. Is that what we're? I think that's what you're saying, Alex. But I just want to make sure I understand the idea. And so I guess maybe I'm being too precious about the idea that that I wouldn't modify this case at all. I've sort of become enamored with the idea that, like, at least it. Don't want to explain. My guitar has one. Oh, interesting. I don't know what you mean. Guitar battery case. This is good. This is what noodling is for. Ooh. Interesting. Ooh. I don't know. Is this the kind of thing you were thinking of there, Alex? Where it like pops open and slides out? I've never seen that before. Acoustic guitar battery. Images. So kind of, but it kind of like pops out there. Oh, Alex, you have an image link. Yes, I don't think you can put link. I think it blocks links in chat. Do you want to tweet it at me? Because we're millennials, I guess, or I am. I don't know what URL is. If you have Twitter, you can tweet it at Jeffers Glass, and I'll get it. That seems like the most roundabout way to do this, but I can't think of a quite a better way. Or you could call me and read off a link to me. Although reading a Google image link, I take it back. That sounds like an awful idea. Let's see. If you 3D printed 20 cases, it's not a huge investment. Oh, the second one on the Google link. Here, this one. Thanks, Alex. Thanks for bearing with me. I see. Well, that's cool. I've never seen that before. I play acoustic guitar, but I not professionally, just casually. It doesn't have pickups. I've never seen this. That's really nifty. It sort of pops in there to power your guitar. Yeah, cool. Yeah, it could become a 3D printed project again, I suppose. There's actually, maybe that's the way to go, is just committing to this being a 3D. And that really opens up a wide world of possibility. And maybe one of the reasons I hadn't thought about it so much is I had originally been envisioning these as metal, just for durability. And they do make metal cases with D-shell connectors, like D-shell connector spaces built into them. And I found these, and they're tiny, and they're plastic, and they're like 50 cents a piece, or like 60 cents, which was very attractive. Let's see. Yeah, so 3D print is definitely an option. And maybe I'm just being precious about this particular case because I was so delighted to find it. Yeah, and that's right. If we're gonna do 3D printed, it opens up a whole world of design possibilities, right? Like this, all of a sudden, all of this business about like tiny OLED screen could become like a 32 by 128 screen, and we could have more buttons, and we could have more PCBs. I don't know why I'm. Here's what I think. I think version 1 of this is going to try and be as sort of low. I think I'm going to try and sort of finish out the version that has a connector on as just the display on this face, just because I think it'll be a little bit simpler, and And I'm it's like a question of like what I want to like chunk the time into, I suppose. But also like there's a part of me that feels like once you have a thing that's this small and pretty rugged and has a little display and control, it doesn't have to just be an RDM configuration device, right? Like you could make a similar thing that was maybe it's DMX playback, right? Like maybe it's just like select an effect you've pre-written and stored in here through an adapter, and then you press a button and it plays it back, and you chunk this down somewhere, and it plays in DMX back for you, or something like that. It's like I guess I'm just a little bit enamored with these cases, but that maybe is a bad reason to. Those cases do have a pro look, yeah, and they're really sturdy. Like I'm really squeezing on this thing and I can't deform it. And I know, most of my printing is in PLA, some of it's in PETG, so I know that's not going to be the most durable. But even compared to like PETG, although maybe they're probably ABS, maybe in a decent enough ABS print they would hold up. Yeah, that's a good way of putting it. Like putting a little bit of effort into making an ecosystem for these cases, which are fairly generic and fairly cheap and fairly prevalent, feels like a good way to go for now. This will not be the be-all, end-all of DMX control devices, and as I look about the messy parts of my workbench that you can't see, like thinking about other DMX controllable things and other form factors, I think I mentioned on a stream or on Twitter, like one of the things I'm excited about is, this is the pocket-sized version, but I have often, this is like the, hey, use his name because he was my assistant at my last full-time theater job. Hey, Alec, can you run up and check the addressing on that string of lights? And take the PocketRDM with you and just go address them 1 through 50 or whatever. That would be great. But I also sometimes want, it's like we're down in the shop, we got to address 40 lights. I want a box that hooks up via USB to my computer and has a really simple bit of software just for like doing basic configuration on a bunch of lights at once. Now, in theory, that software already exists, right? You could get a Net3 node and RDM configurator from ETC, right? That would work fine. That's like you have a Nomad dongle, you have a Net3 node, like we're talking at least $1,000. In theory, the old NTech RDM Pro devices were that, and I have a knockoff one of those. This is the Yarilo DMX Pro, which I feel only a little bit bad about buying because NTech doesn't actually make this product anymore. But and it's meant to be, you sit on your workbench and you say, okay, hook everything up to DMX and I will address them from here. That's great. But none of those products really do all the things that I want them to do. So I think like as I'm holding a circuit board here, something that's like that size and it's got a USB plug and it sits on your workbench and that's your sort of home base RDM controller, and then it's a complement to the PocketRDM that lives in your toolbox and you take up into the grid with you. Probably needs a lanyard hook as I'm saying that out loud. Ooh, lots of good thoughts. What do people have to think? Wonder if that extrusion is available in longer lengths. Oh, possibly. One for a Raspberry Pi Zero could certainly be good. Flexible PETG is a good option. Yeah, I love PETG as a printing material. We use it quite a bit at work. This is a real injection molded ABS part, and maybe that's not a necessary amount of strength, but DMX Cat. I have not played with a DMX Cat in a couple of years. I don't recall all of its functionalities, but that's good to know. I should really look into that. DMX Cat. Yeah, that would be a nifty project. Especially because for so many reasons, running around a theater or a stage or what have you with your phone in your pocket is becoming more and more common because of the variety of things you can control with your phone. So maybe that's a way to also think about it. Yeah, it's a super cool project. Let's see. Worth every dollar. Yeah, yeah. It's a game changer. I mean, the form factor, right? Like it's pocket size. You can take it anywhere and configure anything. Oh no, yes, Kevin's not using his lately. I mean, not that I would have that many places to use it. Although in theory, so for those who don't know, because I know there's some new faces, I think the last time I've said this around here, I worked full-time in nonprofit regional theater for about 10 years as a master electrician at a couple of larger regional theaters. About a year and a half ago now, time is so wiggly, just over a year ago, November 2019, I guess it was. I made the shift. I am now an exhibit engineer at a major Midwest science museum, where they still have me doing a lot of lighting things, because lighting was kind of always a thing that like my boss did, because he kind of knew, and I was like, hey, lighting kid, go do the thing. So I still do a lot of like lighting and DMX control, and in fact, if you'll forgive me, if you'll forgive me a tangent, and I assume that you will because you're still here, one of the problems that's coming up is, and I try not to get too deep into specifics because it's not really my place to talk about behind the scenes stuff, but I think you all sympathize with this challenge. We are going to have an exhibit coming up that is a touring exhibit that's coming to us that is normally in one room, right? It's meant to tour to a big room in a museum and sit there for 6 months and then move to another museum. It's a pretty standard model. Because of the spaces we have available, we're going to put it in 2 rooms, in 2 of our temporary exhibit spaces. But the touring exhibit only has a single lighting and a single sound controller for their various things. And they're touring with all of their own gear, including all their own lighting instruments and everything. But they only have one lighting controller, and I don't know what it is. They have one sound output device and sound rack, and I don't know what those are. The proposition currently on the table is that we find a way to get an unknown number of universes of DMX from one room to the other. They are about 200 linear feet apart, but the shortest cable path is probably 800 or 900 feet through at least, I mean, depends where you go, but at least 2, if not 4, solid brick firewalls. That would be for DMX and some kind of audio. Maybe Dante, I think Dante. Which just sounds, and so they're talking about doing like a hardline fiber run through new places in the building. Yeah, it is. Yeah, I'm really pushing them to put it over the network because there is a building-wide IT network, but they are, in justice to them, reasonably concerned about mixing DMX and SACN traffic onto it, or Dante. Even inside its own VLAN, there's concerns about capability and how much. Also part of it, now we're just getting into the weeds, IT is super strapped because 2020. So I think it's perfectly reasonable for them to say, that sounds great, but we don't have the bandwidth. Totally fair. I love our IT department. They are awesome folks. And when they say we cannot do it, I believe them. Whether that's for technology or time, totally fair. But woof, if we end up pulling like 900 feet of fiber through this museum just to do this thing, I will be chagrined. But we might. And then we'll have fiber between these 2 temp exhibit rooms, and I'm sure we'll use it again. Yeah, Alex B, sorry, I was lost track of chat as I was musing on this thing. The fiber option would work great, and it would obviate us from the need of like troubleshooting with IT, or it would just be a link from room to room. We could say, hey, temp exhibit, here's your link, do with it what you will, that's great. I would love to do SACN over our building-wide network. I just don't know that will be a thing. Ooh, Brokeboth is Dante certified. I've been meaning to at least do Dante level 1, because for my friends who are Dante certified, and Dante, for those, because I know there's like a wide spectrum of people here, it's a way to do lots of things, but mostly to push audio data over an Ethernet network to your endpoint devices, which might be like a stage box that takes that Ethernet data and turns it back into analog sound data to go to speakers, or takes in analog data from a microphone and turns it into digital data, and so on. My understanding is that Dante level 1 and maybe a little bit level 2 are basically just like how networking do, and that level 3 is where the Dante stuff comes in. I don't know if that's been your experience, broke both my arms, but that level 3 is where I would want to get to, because that's the part I really don't know. Oh, Cookie, yes. Or buy a second controller. Even if we had to buy them a duplicate of their controllers and duplicate their show files, that would also work. It's ultimately not up to me. This is one of the joys of leaving a regional theater lighting supervisor management job to going to be an engineer. Is I recommend, I stress, I analyze, I propose solutions, but ultimately it's not my checkbook and it's not my problem, So it's like if they decide that for whatever money, political, anything, they just want to run the fiber, as long as I've made clear, I feel like I've done my job if I've made clear what the options are from a technology and cost standpoint, but I don't hold nearly all of the cards or all of the perspectives, and I'm fine with that for now, frankly. I liked managing people. I thought I was pretty good at it. I don't miss it though. So anyway, don't tell anyone. If future job employers, if you're watching me out there and you're hearing me not like management, please remember we're in the middle of a global pandemic, so can't take anything I say seriously. Let's work on some tiny OLED UI stuff, I think. Let's get the fingers going. I've been ranting at you enough about things. Yeah, second controller would be a thing. But see, Brokebus says level 1 is easy, Intro Dante a little harder, level 3 is networking and harder. Yeah, so I'm especially with Dante's emphasis, it seems, and again, I was a lighting guy, so maybe you don't trust me. It feels like Dante's emphasis is on like, backup. Have you thought about a joystick button? Ooh, I had not. But I like that idea. Where's my mouse? Oh yeah, because it's a wireless mouse, it goes to sleep after a couple minutes, much like the PocketRDM will do. Now, I guess one question I have is there a joystick button small enough for purpose? So size-wise, God, I gotta close some programs or this thing is going to die. Let's see, let's look in here. So size-wise, I have about, let's see, that's about 500 mil, and to the bottom here is about 400 mil of space top to bottom, and side to side. I mean, knowing that this mounting solution is not going to stay, let's say I have roughly 200 to 770, so like 400 by 600 mil of space. And I guess I don't know how small a joystick button would come, but that's a neat idea. Let's see. Oh, let's see. Chris says, looking on info on Jeff for employment. Oh, yeah, I like to think this is just me. I am just a nerd on here, so like, I don't know, if people watch this, I hope they get a sense of like who I am and what I do and what I enjoy, and feel like we don't want to work with that big of a nerd, then good riddance to them. A PS2 joystick, PSP 1000 joystick. Ooh, I don't know those. Let's check those out. PSP 1000 joystick. Ooh, you could get them from Adafruit. Analog. I guess digital would be slightly preferred, but it doesn't really matter. Like with a clicky kind that just clicks left and right. What's the size on these? 750 mil square. So that's a little bit big. I might be able to squeeze that in, but like I say, I only have currently 400 mil sort of top to bottom here. Let's see. So that's even on that PSP, that's a little bit large. Let's try DigiKey. What did I search here? Joystick? Just see if navigation switches. Let's do normally stocking just to give ourselves a slightly fewer options. And let's start with size, because I think that's going to be the limiting factor here. I mean, frankly, even if it was only like a 2-axis device, right? Because right now, the thing to beat, right? The time to beat is 2 momentary buttons, right? Which I think is what I have on hand tonight, so that's what we'll probably start with. But anything that gives an additional axis or button of control, and there might be a way to squeeze a third, even smaller one in here, but right now, let's see here. Panel cutout dimensions. That's not quite the same. Although I'm not entirely encouraged by the smallest panel cutout dimension here being 12 millimeters diameter. That's already, I think, more room than we have. Panel cutouts 21 millimeters by 10 millimeters. That's interesting. That would almost fit. What's 21 millimeters in mil? 800 mil? Because didn't I say we have basically 700? How many millimeters do we have here? The interior of this case is 22 millimeters side to side. Okay, so that's not a crazy thought. The old guys in my crew will hate the small screen and buttons. That is certainly true. I mean, I'm delighted by how readable this is, but it is still tiny, for sure. Yeah, it is not. That was originally what drew me to like I can't remember if you were here for this, Kevin, but like the 3-digit 7-segment displays, because you can cram one of those in there, but again, the UI options are just so limited. It would require memorizing a lot more of what button does what when. I actually worked up, we're just down the rabbit hole this evening, like a whole flow for how a 3-digit display might, let's get over to the thing, might represent various states of control, right? So it powers on, it shows DIS, and it would have, the buttons would be labeled enter and an arrow to the right, sort of like next. So if you hit enter on discover, it would discover devices, and then you could, it would say ADD, and you could use that to address them. So I worked through this whole flow of how 3 digits would be, sufficient. I don't know, end would be a little bit funky to display. But you would have to sort of memorize this flow, or, it would not be entirely transparent. Okay. Kevin says that's a plus. Big LED that blinks out in Morse code. Yeah, that'd be cool. As I pull up this joystick page to continue this hunt, one of the coolest escape rooms that I ever did, of course, in the before times, was built by some former theater people. And these are not going to be the thing. Look how giant, look how clunky these are. They're huge. I see, they cut out in a panel. That's what the actuator goes through, but the joystick is super, super proud. Well, that's not quite the thing. What was I saying? This escape room built by theater people. One of the things that it had in it was it was a whole fake CTA car, an L car, our elevated subway here in Chicago. Elevated subway might be an oxymoron. You're over here. Hi. Now you're over here. Hi. It was a full CTA car, full train car, and one of the stops on the red line here in Chicago is the Morse stop. And when you activated the train to get your next clue, one of the things it would do would blink the little red LEDs like they have in our maps on the train. They blinked the LED at the Morse stop in Morse code to give you your next clue. Super clever, super cool. I happen to know Morse code, so I kind of jumped ahead a little bit. But one of the clues was to find a Morse code key that would tell you how to decode Morse code. But there you are. So these are not quite navigation switches joystick. I'm missing something here. Let's see. I want something more like this, a little tiny navigation switch. Let's see. Alex would love to build an escape room. Yeah. Yeah. We'll get to AliExpress for sure. Yeah, building an escape room would be super fun. I actually had a friend who worked at this escape room company where this train car was before escape rooms were not a thing for a while. And I was like, hey, if you ever need anything, or can you just introduce me to the people who built this, because they seem super cool. And then actually one of the women who built it was our operator for that evening. She was training somebody new and was our guide essentially. She was awesome, super cool. The person she was training was also very cool, but she was I was like, can I take pictures? And she was like, only if you swear never to show them to anyone, because that's all the secrets of the stuff. I was like, yeah, whatever it takes. I just want to show this to a bunch of nerd friends. Let's see, where's a drawing of this thing? This is just literally the first result on DigiKey, just for a sense of size. So this one in particular, for example, is 350 mil top to bottom, 303 mil side to side. Hey, this is cool. This could be a part. DigiKey part key. 11 weeks, 2-axis digital mechanical switch output. That's what I think. That's what I think we want. Because I think the analog ones are going to be a little squishy. Yeah. 5-position navigation switch. 5-position normally open. So what I'm wondering is if this has a, yeah, it does. So here, look at this pinout diagram. So you get 6 contacts, common A, B, C, D for your 4 directions, and then center with a normally open switch for press. So you get joystick and press. That's cool. That's a better interface. The trick about that interface is, and again, this is all assuming we're still in, you know, the the little, what is this brand called? The R connector form factor, right? One of the tricks about that is like with 2 buttons, and I'm not saying the joystick is a bad idea, I think it's a great idea. With 2 buttons, we have the ability to sort of label what each of them will do on the screen and still have our sort of primary display. With 4 buttons, that gets a little bit, just a little bit less control, but probably having the joystick button is going to give us some more intuitive options, right? Like we could say, you know, I'm imagining we're in the like set address mode and maybe 1 digit is blinking, and if you do like up joystick, it increments. If you down joystick, it decrements. Left and right scroll you back and forth with the digits. And then down here, maybe the buttons say, you know, confirm or back or something. And that means what you press the joystick button to do one thing, and you press probably a second momentary button to do something else. Also, do the buttons have to be on the front? They don't necessarily. Yeah, Alex, it's totally true. Like, if we were to go into the side of this thing, we could certainly go bigger. I'm just being precious about this form factor. And there's, from an from a design for manufacture point of view, being able to get these whole and not modify them is really attractive. One thing that I have discovered in making the tiny moving lights is that any commercial part that you have to modify, at least, and let me be clear, I'm not like a manufacturing guy, and I don't plan to make a huge load of these or make my fortune off this, but as someone who's like, I want to make a batch of 50 of these, any way that I can eliminate the need to modify this, or modify whatever I take in is just time savings for me, which is an advantage. So I guess I'm still, if we're gonna do this part, I'm not gonna modify the sides, but maybe this isn't the right part. Maybe we go to like a 3D printed form factor. This is just sort of what I guess I'm sort of taking for granted that this is a limitation that I'm gonna be under for now. 4-page, homepage and 4 pages for different directions. Just memorize where each page and function is. Center could be something else too. Yeah, so maybe we get into this UI a little bit, which nominally was what we were going to work on all of tonight, but we got excited and down rabbit holes, and I'm not sad about it. Let me get a joystick out to play with, because I'm sure I have, probably not a digital joystick, but we could simulate one. I guess we could either simulate one, or we could use like 4 push buttons. Let me see what I hear. Enjoy my tummy while I grab a joystick. Because I don't think I have one of these like digital 4-direction button joysticks. Get rid of this keyboard again. See this? I just love it. I can take it up, I can type, I can put it down. Let me see what's in the old bin. Oh yeah, right here on top. It's gonna be a little funky to work with in a breadboard. But I have, still new in packaging, these are the right type. Look at this. They're not analog. Maybe they are analog. Yeah, they totally are. That's just the switch on the side. Click, click. And then they have 2 potentiometers, 1 and 2. And they have, what's our pins here? Ground, we'll zoom in. Probably won't focus quite that close. Ground, 5 volts, VX, VY, and switch. Yeah, so not quite the part we would use, because again, I think, and correct me if you feel otherwise, I feel like the like clicky, like 4-directional switch is the way to go, as opposed to analog. I mean, also just for size, but this will be good enough to prototype with. Track point? I don't know what that is, but I'll Google it. Pointing stick. Oh, like a nubbin, like a Lenovo, like a ThinkPad nubbin. Yeah, could certainly do. I bet that's not that far off from like what some of these parts are. Also, again, analog, which is I think more than we need, but it's kind of interesting. Clicky, clicky. All right, well, let's get this set up for some prototyping. I think I'm going to need a slightly bigger breadboard is going to make my life easier. I'm going to get rid of some of these extra wires here that I was using for testing. Let's see. I think a slightly bigger breadboard, which I think I have some spares of back here. If not, I will free one up. Yeah, there we go. this is my bin of all of the breadboards that I have, and also all of my old electronics bash projects, which was, and some of you may be wondering, what I had been doing was like alternating weeks of working on Demilight projects and what I started sort of streaming for, which was electronics classes on Arduino and Raspberry Pi programming. And this would normally have been like an Arduino-ish, Raspberry Pi-ish week. I know like Nate has been here for so many of them, Chris as well. And I'll just be totally honest, I had an idea, I had a thought, and I just, with the state of the world and myself, I just couldn't quite get my brain in the right gear to put a class together this week. I had a lot of fun noodling around with the Demilight stuff and the PocketRDM stuff, but I just could not quite, like, I had like 3 full starts in working on a class for this week, and I just couldn't. I think it's, it's been a little over a month since I have been back at work, which I feel very lucky about. That's not a complaint. I'm grateful to still have a job even now. But I'm just like, I'm hitting a weird point in like, just like quarantine life, trying to get my brain to do things sometimes. So I decided, rather than try and force myself to put together this class on a topic that I wasn't totally confident in to begin with, I figured we would just sort of punt and do some more noodling, which I know people enjoy. I know there are people who have been here for so many of the classes, and I do hope to do some more of them, but I hope you'll forgive me, I just couldn't quite get it this week. Let's see. All right, I'm just getting my display moved over to the new breadboard here. Chris is confused but not disappointed. Yeah, so one thing I've said before is like a 2-week cycle for these Demilight products had turned out for most things to be pretty good, just because like the lead time on a lot of stuff works out to be like about a week, and so I get about a week to I've messed that up already, to like, do a stream and then spend a couple days, order something new, get it in late the next week, do some basic tests on it, and then it's good for like, a 2-week cycle works out. And this week, just like diving into this new PocketRDM project, there's just like a lot more stuff that I can work on. So, all right, get rid of the small breadboard. Enough about me and like my maudlin quarantine life. You didn't come here to talk about that. We never really did answer the question of what the heck we're gonna do about battery power, but that's okay. We've got time. Let's see. And let's just make sure that this still works. Now that I've moved it over, it does not, but I suspect I know why. A lot of these breadboards, I should say, have a break in the ground and power lines right in the middle here, and I bet that's what's happening. Let me grab my meter here. Yeah, we do like the shiny here, Chris, don't we? So I suspect, unless I've gotten these back. Let's turn this to connectivity, and we'll just double check. Oh no, we do have connectivity there, and there we have our ground hooked up. Oh, we don't have power hooked up. That's why. The 5 volt. I have ground hooked up twice, and I don't have the 5 volt power going to anything. Well, that would do it, huh? So that would be VCC to positive rail. Let's reset that. Still nothing. Why would that be? Well, good. Troubleshooting is the other thing we like to do around here. Sometimes with fire, hopefully not. Cookie, I hate, I don't know that the scale of the things that we're doing tonight, Cookie, are going to really lend themselves to fire. So I have 6 volts here again. That's exciting. I guess one question is, did I get the SCO and SDA lines backward from the Arduino? Which is possible. But there's no harm in reversing them, I don't think. There we go. Yes, I wired it backward. Well, that would solve it. Like I say, I'm not really a streamer. I'm just a guy who does electronics and likes to share it. But there are a couple of people over on like Twitch that I do sometimes enjoy watching, and I gather that like gambling with your Twitch somethings, your Twitch bucks is now a thing, your Twitch points. Anyway, all to say, if we were gambling here, it would be like voting on like should there be fire or not, and I would always bet against, because then I know all of you would vote for, and it's all in my hands. I mean, it would be insider trading or whatever the equivalent is, but I would clean up. Wonder if we want to take this. So right now, what I'm saying, I mentioned earlier these would not be super great for breadboarding because they have this right angle header, so it's going to kind of sit like that. I might take a hot second and just replace these with a through hole header just so they can sit flush with the board. Actually, before I do that, I'm going to see, I have another bin of modules back here. I might see if any of them have that configuration first. Potentiometer, distance sensor, fire and flame sensor, cookie. Let's see. I don't think the joystick modules are in here anymore, which might mean they're in that other bin. Let's see. Various wires. Predictions with bits, I see. And bits are equivalent. Bits are basically cash. Is that right? Like you buy them with cash, and then you contribute them to the streamers, I think, or something. Like I say, I don't really understand, but ooh, here's a joystick module. Let's see. Oh no, this one's the same way. This one also has those right angle headers. This one looks very similar to the other one. Let's get this back on there. Doesn't get lost. There we go. I'm not seeing other joysticks, so yeah, I might take a hot second just to reconfigure that one. Let's turn the soldering iron on. We'll put the safety glasses on. Just because I know someone asks every week, I would normally be soldering. I have with filtration. I tend not to turn it on during the streams because the sound of it is really intolerable in earbuds, but for like 5 desolder joints, I think my lungs can spot me one. Let's see. Channel points. Channel points that can be accumulated from hours watched, not person. Chris is gambling. Chris is. I don't know what 13% of what, Chris? 13% of fire? Let's see here. I'm gonna need some solder wick. Oh yeah, like my bin O soldering stuff. I've been organizing. So the folks who were here last week know I've been organizing my tool storage to prioritize the stuff that I use most frequently. Geez. Just so it's all within arm's reach, and that's partly only possible because, as I said before, I used to have like 10 different things I wanted to do and try, and now as my hobbies have become a little bit more focused, I can really say like, okay, these are the dozen tools I use most often, and so I should put them, close at hand, and that's a feasible proposition. I have lots of other things close at hand around here as well, but having the screwdrivers and soldering iron and miniature files close at hand as opposed to the other things, I suppose. What's the tools that are farther away? DC load tester doesn't need to be close at hand. The other screwdrivers don't need to be close at hand. The variable power supply is right there. Like, just trying to become a little bit more focused about it. But that's new in the past, not very long. It's one of these things that like I'm a nerd, as maybe most of you are as well, maybe all. And sometimes it's like, oh, I want to try that. Ooh, that's a cool thing. I don't know how to do that. I want to do that. And so it can sometimes be a little bit hard to know how to like organize space. Oh, getting my camera in the camera here. Well, that's okay. Just for soldering times. And then we'll move it back out of the way. It can be a little bit hard to know how to organize space given that there is so much that the workbench has to do. And it's only really by dint of like finding these few projects that like now I'm like, oh, I want to really commit myself to completing some of these, the tiny moving lights, and what have you, that it's like even possible for me to begin thinking about having one set of tools that covers most of my hobby interests. I guess what I'm saying is if your workbench or your work area is not terribly organized, don't feel bad, because mine isn't either. Then you have situations where someone like Chris. This is not. I don't think it's spoilers because you mentioned it earlier. Chris is a props master for theater, and like that is a whole other level of having to do multiple things, right? Like just the number of materials and processes and finding, making, modifying, painting, gluing that just come with that job. I have been constantly impressed by the prop masters in my life ability to even begin to like organize themselves in a way that helps. Jack of all trades, master of none. Yes, absolutely. It's like, well, we need this thing. What new technologies can we draw in today? Or like, what's the or do we just buy one? Constantly impressed. Let's see here. This is being a real bummer. Let me put a little extra flux on here. I have these, I really like these flux pens. I have a vial of flux as well, but I really like these like felt tipped flux pens. They're really easy for just like, I just need a little more flux on here. See if that makes my life a little bit easier. Get in there. Not the most fascinating part of the evening, I am sure, but I think it's gonna make the process easier going forward. You know what I should do is really chip these apart. So I don't have to desolder them all at once. Ooh, coming. Yeah, there we go. So I'm gonna trim that top part off. And I can already feel these pins coming loose. Yeah, there's one's loose. Let's see, what else is loose here? Yeah, now I can sort of desolder and prise these pins out one by one. No solder sucker. So I do have a solder sucker. The problem is at this point I need to get the physical pins out first. And I guess I might have some luck doing the solder sucker around the pins. Actually, now that I say it out loud, I don't know where my solder sucker is. That's a problem. That should probably be on the shelf. I've said before, I don't really love using a solder sucker. It's really nice for clearing through-hole pads on stuff, but I don't find it the sort of general purpose desoldering tool that a lot of people do, but I might just not be using it right. Because this, honestly, maybe this is the time to be using one. Ooh, this is really spinning on me. Let me tighten this up a little bit here. But I find solder braid to be, in most situations, pretty much all I need. Although clearly this is going great. Let's see here. You know what I should have done is just bent the pins on that other... Oh, no, those pins are on the top. I think they would bend the pins on the other header to be straight and just stick them in a breadboard, but that's not how those pins were oriented. Let's get this thing to grip just a little bit more tightly. I think this will pay off so we can all see what the joystick is doing as opposed to having it kind of hang out at a weird right angle from everything. Can I take as I'm doing a relatively manual test, can I take a poll of the group who's out there tonight? It's a very simple question. Leaded or unleaded solder? And why? Because I have opinions, and I think I've shared them before, but a lot of you I don't know that well, and I'm curious. Chris, it's not Twitch. It's YouTube. Is there a way to poll on YouTube? I guess I don't know. But I would be curious, those of you who like if you solder frequently or infrequently, I'm equally curious where you fall. There we go. That's 2. Cookie has not used unleaded. That's totally fair. Still have lots of leaded. Yeah, I mean, at the rate one goes through a pound of solder, right? It's like, oh, was given a roll or got a roll of leaded years ago, and I haven't used it up yet, so why would I buy anything else? That's a totally valid answer. What else we got here? Thomas says leaded all the way. Yeah, leaded is so much easier. So I have used some unleaded in my time, but I just like all of you, it turns out, I am a leaded solder guy. I'm a 6337 if preferred, but just like you, Kevin, the roll I'm using now to wet the tip a little bit here is 6040 because I got it years ago and I haven't used it up. So why would I change? The roll I have so I have a slightly smaller roll for doing surface mount stuff, and that is 6337. But yeah, we're all in agreement here. It's for commercial projects, especially if you have the ability to, wave solder the thing or do it on a circuit. Like, of course, like you have the engineering time to figure out how to do it with lead free, and ROHS requires it. Then manufactured products, I think, that are going into landfills by the tons should be lead free. But like for all of us, it's just so much easier. Dave, yeah, well, just chomping a little lead. It's always a tasty thing. I think it was back in the day when I was doing the series of Arduino-based classes, and I think I had an evening on soldering. Those are all still up on YouTube, by the way. There's a playlist called Electronics Bash if there's topics you guys are curious about and again, like I say, I'm not an engineer. I'm just a maker and a nerd, but sometimes that's a useful perspective. You can go find those. There's one on soldering, like introduction to soldering things, and I think Chris called me on something like, now remember, if you're using leaded solder, make sure you wash your hands after before you eat or drink anything, as I took a sip of beer. So do as I say, not as I do. I mean, a sip of beer in a can, I'm not so worried about, but like, shouldn't go like eat a vial of grapes or something. A vial of grapes? Stand by. Yes, more beer will help, I'm sure. All right, well that's done. Thank goodness. Let's take this aside. A vial of grapes. Wine. Yes, wine is, I'm sure, what I meant. Yes, for sure. That's just science. This, by the way, super cool, super useful soldering stand for circuit boards. You can find them on Amazon. They're super cheap. I think it was a birthday gift at one point. I was like, and I looked afterward. They're not super expensive, but I love it. I think my dad got me this. It's just like, it's got little fingers. It's adjustable. It's flexible. So, excuse me. It's not super great for holding general purpose stuff like a pair of helping hands is the word I was looking for, like a pair of helping hands would be, but it's really nice for holding circuit boards. Where are we at on the menu? Oh, yeah. So I have not been advancing our agenda for tonight. I've lost track of whether we're in the shenanigans part or the fun part. That's fun. All right, so let's get this wired up. So 5 volts and ground. Oh, because it's got potentiometers into it. That's why. I was like, why does this thing need 5 volts? It's passive, because what it is I'll zoom back in here. It's an X potentiometer, a Y potentiometer, and a little button on the outside that gets pressed when we click it. That's all this thing is. Let's see. So I'm gonna insert my hat back in there. We'll have to do a little bit of glue code just because this is an analog joystick and we're going to be using it like it's a digital joystick for tonight. Do we need a second button, I wonder? Or is this going to be enough? I don't know. The thing that, well, let's not for now. The thing that I think of for a second button is like a generalized like back button, like have the press be enter and have the like a secondary button be exit, cancel, go back in the menu system might be a useful thing to have on a separate control. Oh, I am just, so sorry, off camera, I am just pulling out a bunch of DuPont wires here so we can do some cabling with. Normally I have the camera set up a little bit higher so we can see more of the workbench, but this display is just so wee and so adorable that I figured we'd get in sort of as close as my autofocus would tolerate, so we stand some chance of seeing it on the camera. Oh, Chris, sorry, yeah, to be clear, the joystick does click when pressed down. What I'm curious about, because I think we have space, is do we need on our control board here a one joystick button and one just clicky button for some purpose? But no, the joystick does indeed clicky. Not very satisfyingly, this one in particular, but all right, I'm gonna unplug this just for a second. We'll get this wired in. So what do we got? We got 5 volts. We've got ground. Green for ground, sure. I don't know what kind of contact the switch is going to be, but that's okay. We'll figure that out. We will hook up our potentiometers. Our X potentiometer will go to, let's call it A0. Our Y potentiometer will go to A1, and our switch will go to something else. How about pin 7? That's a good pin. Here, let's take it to pin 12, because that's nearby. There we go. Okay, so that's wired up. Unless you have to press 2 buttons at the same time. Yeah, potentially. All right, well, there's that. Let's write, I mean, we're gonna have to do, like I say, a little bit of glue code just to like make this thing work, but let's get a little test program written here. So I'm gonna close, I can leave Eagle. I think we're doing okay. Let's write some code. We're finally writing some code this evening. Let me first, as all good code begins, steal the start of my code from the existing display program. This is going to be a microcontrol. Microcontrol screen and joystick test, we'll call this. Let's see. And I'm going to steal my so I wrote a function here, and I'll go through it real quick, called show display, that takes basically 3 arguments and turns them into displaying one called the big string, the left string, and the right string, which are this string at the top, which can be up to 6 characters long and is automatically centered, and then the left and the right are shown in this smaller font, white on black, and are automatically squidged up against the left and right sides at the bottom of the screen there. So let me just copy and paste those over, and then we'll go through them real quick for those who enjoy that kind of thing. Let's see. Let's steal from this and this. Okay, so here's what's going on in this code. Let's see, is that going to be big enough to see? I think so. I mean, if I get rid of the table there for a sec, that's a little better. To work with these little OLEDs, in case you want to get some to play with, and this is the same across all the SSD 1306 controlled OLED screens that I've run across, modulo the slight modification we talked about at the very beginning of the stream with tweaking the code so that it displays properly on the little tiny OLED. You call this display.begin function, which is a little bit of setup with the screen. In particular, it tells it to turn on the boost converter, so it generates its own high voltage internally. Oh, this is very funny. The Adafruit library, when originally released, apparently had an error in its code table that told it what characters are what. It was missing 1 character, and so every character after that was misindexed, but they didn't cache it for I don't know how long. And so a lot of code had been written assuming the previous character set was correct. So now if you want to use the actual character set, the code point 437 table, you have to set the CP437 function and give it the value true. And then you're using the real code point table instead of the Adafruit screwed up table. So that's just going to initialize our display there. And then this show display function. So it actually takes 5 arguments: the string, the big text, the left text, and the right text, lower left and lower right. And then it takes 2 booleans, big left and big right, two true or false values, whether to, if those are true, then the text in the lower left and lower right will be this larger font size. If they are not true, which by default they are not, it'll be this smaller size. That was part of an experimentation I was doing. I don't really see a use for that, but there it is. Then we have a bit of code that calculates the length of the large text and where it should be centered on screen. We draw a solid white rectangle behind it because there's some slightly strange behavior with how it, with how the characters print out. They sort of appear right at the edge of their bounding box. So we put a white rectangle down first and then draw black on white text on top of it just so it's nice and clean. We put our cursor in the lower left and write our text, our small text to it there. We put our cursor far enough in the bottom right corner that nothing's going to run off the screen, and we print our bottom right text there. Then we call that display function that actually pushes all of this out to the screen. And then we wait 1 millisecond. This is a little bit of cargo culty. This is what all of the Adafruit examples for this library do after they display, is wait 1 millisecond. I don't know if that's critical or not. So here we are. And then I just have an additional function that just says if you don't specify either of those booleans, big left or big right, it will default to them being small, because that's most of the time what we want. So let's first put in a bit of code that I think what we're going to do is just like when we move the joystick around or click it, it will just tell us on the screen what we're doing. So let's define a few constants. Let's say const int, let's see, so we've got vrx, vry, and switch. Const int vrx equals, what pin is that in? A0, I think it is. Make sure that's right. Vrx is in A0. Const int vry is in A1, and const int switch is in pin 12. We'll set all that up in our setup function. We'll say pin mode, vrx input, pin mode, vry input, and pin mode switch input. I think this should be input pull up. I guess I don't know what it's defaulting to. Let's do just a quick measurement on the board here, because I don't know if it's normally open or normally closed, if it's being pulled high to ground or not. So let's just see what's going on here. Let's just do a little, let's take the, I guess we'll do this with power applied, and we'll just measure the voltage on that switch pin to ground. So on that switch pin there, it's not a ton to see at the moment, but that's all right. I'll just get the, get ye olde multimeter in there. Switch is current, but measure volts. Volts are cool. That is currently at 0.5 volt to ground. That's a choice. If I press the button though, it goes to 5 volts, and I release it and it goes to ground. Okay, so I don't actually need a pull-up on it there. That can just be a normal input, so that's nice. Thomas, oh, I missed this, Thomas. Green for ground, yes. So it's protective earth in a sense, that it's protecting me from not having a ground, right? That seems fine. Okay, so let's write some code here. So we'll say, right at the beginning, let's just say, show display none, and empty string and empty string. And actually, before we get too much far, let's just upload that and make sure it's right. SSD 1306. A bit of a typo in the code, and we'll upload that. There we go. We'll just get this to play nicely first, and then we'll go on to some UI shenanigans. None. So nothing is pressed currently. And now we'll write a bit of code to make sure it actually does a thing. So we'll say if digital read switch equals low, show display. I think I can fit 6 characters of that larger text. So it's oh, you know what I should do is I'm gonna have to figure out which sort of direction these potentiometers operate in, but I can use the screen to help me out here. So before I do this switch code, I'm gonna say is, let's see, X value, and I guess I don't know that this is X, but what I don't know that what am I trying to say here? There are two potentiometers on here labeled VRX and VRY. It's not clear to me which axis is meant to be which, though I could take a pretty decent guess. But either way, I can just say, I can sort of define my own X and Y. So I can say pos X equals analog read VRX, show display, string pos X, nothing, nothing. So we'll show up on our little screen here what our VRX, int pos X, of course. It'll show up on our little screen here, if I put the right semicolons in, what our reading on that potentiometer is, and that can also sort of figure out which direction means which. Because for my purposes tonight, I want this to be left, this to be right, up and down, right? And whatever it is internally doesn't really matter to me. Because I think it's going to help us sort of navigate things. There we go. Ah. Well, that's no good. Oh. Someone's calling. You probably won't be able to hear them, but I can. Hello. Good, how are you, Josh? Oh, hello, thank you. Are you watching? Thank you, I'm glad you enjoyed the stream. My gosh. Sounds good, Josh, I'll talk to you soon. Bye. Josh, you are a great person. It just gives me such joy when that thing rings. It's interesting. So I have actually, this little secrets. I actually have two phones hooked up. I have the bat phone behind me, and then up on the wall here, I actually have a biz phone hooked up to the other port on my analog telephone adapter. And I thought I had turned the ringer off on that one, but I heard it sneakily ring just a little bit before the red phone kicked off. So I have to figure out what's going on there. Let's see here. Yeah, it's like I was like, what the heck is that? Biz phone ringing. So something is not right here. This should not be constantly high, unless the module is broken, which it could be, or I've wired something wrong. Ah, yes, I've wired something wrong. I have not plugged the ground into the ground, which means it's always just floating up at 5 volts. Oh, ground is ground. 5 volts is 5 volts. Let's try this again. There we go. Yeah, okay. So now this is showing. When are you going to add that audio into the stream? I mean, if I could figure out a way to like route the SIP call. I mean, there's probably a way to do this, because it's all VoIP calling at the end of the day, and it just turns into analog telephone data when it gets to me. So I could probably route it to like Voipier, or Zoipier, or whatever it is, that's like a computer phone program, and then like route it in. All right, good. I needed more projects, Chris, so that's, thank you for suggesting that. So what I'm seeing here is when I push this up, this goes to 0, push it down. So that's the built-in X direction, and this is the built-in Y direction, so we get 10th that. Josh McCammon's in the chat now, thanks. Oh, I've lost this webcam again. This happened the other week too. I actually think I've determined what's happened here. I'm having an issue with one of my USB hubs that's causing this. I was gonna turn Frozen Jeff off there, because I don't know of a great way to do it, to fix that other than like unplugging that entire USB hub, and I frankly don't know what else is in there. But that's not really the interesting view of me anyway. So yeah, actually I have the replacement hub just here on the desk beside me, and I've been too focused on little tiny adorable RDM devices to replace it. So let's see. So in this case, I should probably make notes for which direction is which. VRX 0 and 1023, and that means VRY. So let's go do the same code test here. You know what? Actually, I'm gonna take half a second, because I might actually be able to fix this just by deactivating and reactivating that webcam. or I might not. Last time it came back on its own for a little while. What I'm going to do now is just change, add in a variable here called pos_y equals analog read vry, and we'll have the display show our y position here. Hi. So you only get this view, but you won't get surprise Jeff view over there. We'll just leave him as spinning circle Jeff. Oh, I guess I have to turn it back on. Turn it back on. I guess. Oh, I can put this camera view up when I do the coding, but like you're going to be looking at, well, maybe I'll just leave that because that's just sideways Jeff for a little while there. All right, so now table-wise, so VRY is left, right, so max and min. So it's VRY is 1023-ish over here and 0-ish over here. So now we can sort of turn that into states. So I'm going to say, we're going to define a, I'm going to have to look up, and I'm not ashamed to look up things on stream, as you all well know by now, what the proper syntax for defining an enum is. Yes, enum. Because I think we want enum open and commas. Okay, so I'm going to define an enum called my button state. And we're going to have various states called none. Let's do lowercase. We'll do none, switch. I can't say switch. I'll say SW, pressed, left, right, up, and down. Let's see. You're about to the point where we need a crew to help maintain the camera view switches. Just park production. Yeah, you can pull it behind the alley. You can set up. I've got a basement right below me. You can set up in the basement. I feel a little weird about just looking at the side of my face there. Maybe we'll just put back to spinning Jeff for this view for now. I guess. Oh, I'm gonna try one more thing. I guess, to be honest, I don't know for a fact. Oh. Yeah, I do. I want to say it might not necessarily be this USB hub. It might be my computer and this USB hub in combination with each other. But the other thing is, as I've discovered in the past, OBS, the streaming software that I'm using, is most... Hey, there we go. Of course, it's lost on my presets, so I'm a ghost again. But is most happy when all of the video devices are active when you start the software and you don't change anything. So as soon as that camera goes, even if it in theory comes right back, I don't think that OBS would be happy about finding it again. That's close enough. Hello again. All right, so now we have this enum for our button state, and I will say enum, I guess button states, and I will say int state equals, what's our syntax for referencing an enum? C plus enum. Yeah, Logitech's drivers are, for their cameras, are not great. Switch R, K screen. Okay, so I think I can just equals none. Can I just define it like that? Will that compile? Oh, did I define state twice? Two or more. Int state equals an enum, then I don't, it's not something you would use like in a Pythonic environment, but an enum is just a way of having, like, for example, I need this, this variable called, like, I'm going to use a variable to hold what state the joystick is currently in. Is it nothing happening? Is a switch being pressed? Is it the left or the right? And so on. And I'm going to need to reference that value, and I like to do it by name. So what I could do is define each of these states as like a number. I could say, you know, none equals state 0, and switch pressed is state 1, and so on. An enum is basically the same thing, except you don't actually have to explicitly define what those numbers are, because we're never going to reference them by number. We're always going to reference them by name. So here's a good example, right? So define an enumeration of colors, red, green, blue, and then switch what color your variable represents and print the name of that color out to the screen. But I'm just, oh, do I need a semicolon here? I might. Yeah, that's what it was, because of the statement. Cookie uses logic capture. Yeah, I've looked a little bit at logic capture. I haven't found it to be any better at preserving my webcam settings, but maybe I'm just not using it right. I haven't really explored it very much. All right, so Cookie, this is, Thomas, this is the benefit of an enum. I can say my current state is switch pressed equals none, and then later on, I can use some logic to determine and set the set of that state variable. So let's just do that. We'll just say if digital read switch equals, it went high on press, I think, equals high, state equals switch pressed. Else if, and I'll have, these are going to kind of have to take priority in some sense, but I think that'll be okay. So analog read, let's see, so left is VRY, is greater than 950, let's say, state equals left. Else if analog read VRY is less than 50, and we're leaving ourselves a little bit of slack at the end of each of the travels of these potentiometers here. Alpha if analog read VRX is greater, is less than 50, state equals up. Else if analog read VRX, is greater than 950, and I'm seeing I have some typos here, because those should be outside of those parentheses, and that should have an extra parenthesis. Is greater than 950, state equals down, else state equals none. We'll just make sure that compiles. It does, which is great. And here, let's wrap this all into a separate function just to clean this up here. We'll say void get joystick state. And you know what we should do? Instead of using a global variable like this, in this situation, we'll use an int. We'll say int return state equals none. And rather than setting the global state variable here, we'll use this temporary return state variable. And we don't need to set it down there. And at the end, we'll just say return state. All right, so now in our loop, we'll say state equals get joystick state. And then we will print some things out based on that state. So we'll say string disp string equals none if state, I guess we could switch on the state case switch pressed should be disp string equals button. So we're basically just writing a little bit of code here so that we can make sure that our joystick is behaving properly and we can see what it's doing. Case left, disp string equals left, and we'll have it print this string out to the display in a second here. Hopefully, Thomas, this is starting to make a little bit of more sense why you would use an enum in this case, right? Because I never really care about what the values are under the hood for the different states that this variable can be, and I'm only ever going to sort of compare it to itself. So it's a good way to have like a variable that can only take a set of values. And then once we've determined what we're going to print out using the state of our button, we will use our, here we'll say that we start in the start mode here. Now, just to start us off here, what I'm going to do is a really lazy thing and only have it update every quarter of a second, rather than say like every time it changes update. Let's try that. Get joystick state was not declared in the scope. Yes, it was. I just declared it. Where is that function? I probably misspelled it. Int get joystick state. Or I'm missing a parentheses. That's also likely. I capitalized it in one place. I did not capitalize it in the other. That would do it. Switch pressed has only 2 S's, Jeff. There we go. All right, that compiles. Let's upload that and see if it works. As I take a little question. Ah, Chris, I was muted the whole time. Well, that's one. Whoever bet their channel points on one mute before 9:45, you win whatever you win with your channel points. There we go. So now when I go right, none, left, none, button, none, down, and up. Interesting. I mean, this particular joystick, it seems to like sometimes have the button be pressed when it comes back to center here. Maybe I'll reduce this update time to like 1/10 of a second just to make it a little bit more snappy. Well, that's a good feeling. Nice. Well, now we can use that to start finally writing a little bit of the UI for this thing. And we're gonna have, this is a little bit cart before horsey, I will entirely admit, because I have not finished the library that does the actual RDM control yet. I'll say the place I got hung up and I was sort of procrastinating because I had to make a design decision, is right now the JDMX library, which is the library that I'm developing to do this, which is a fork of the Conceptinetics library, to be totally clear. Most of it is not my work at this point. Currently, everything is interrupt driven, and you don't need any additional timer configuration or polling to make it work. But for the specific functionality of when you send an RDM message out into the universe, your controller is supposed to wait 2.8 seconds 2.8 milliseconds for a response before carrying on, maximum. At least 176 microseconds, no more than 2.8 milliseconds. And to accomplish that timeout, I either need a timer-based interrupt or polling to make that happen. And I'm reticent to add either of those into the code base as it is, but my shower thought from literally this morning as I was thinking about this stream this evening is I think it is reasonable for an RDM controller, right? So not the code that's running an endpoint tiny moving light device, but literally a controller to, when you say, send RDM message and wait for response, for that function to basically hold the device, and that, to be clear, not necessarily hold it against any interrupts, right? Because it's going to still need its serial receive interrupt to receive the response. So it shouldn't mess with millis or servos or any of the hardware-y stuff. But to hold in that function for 3 milliseconds while it awaits that response. So I won't have to reconfigure any timers. I don't have to set up any new interrupts. We're basically just going to hold and wait for a response. And if it doesn't, we'll time out and we'll do something else. That, I think, is the right answer. I think that's a better design decision than, like, introducing, this RDM library controller now makes use of timer 0 on the controller, and you can't use it for anything else. Makes it more versatile that way, I think. So that's what I'd been hung up on, that bit of like, library ethics for the better part of a week now. But I think that's going to be the solution that I'm hanging on with. something is bouncing here in a way that I don't love. Yeah, something about this switch input is funky. Right? Like, that's not a great sign here. Maybe I will just reset and see if that persists. Right, left. Yeah, something's a little bit... I don't think it's debounce on the joystick. I think it's the mechanism in here. I mean, I'm going to need some debouncing on the inputs regardless, right? But like currently as I'm moving this actuator, I shouldn't be changing the state. I wonder if I do need a pull down. That might be good because it goes, let's see, low is pressed, high is pressed. Let's remeasure this. I think let's grab our voltmeter here, and we're just going to remeasure what's happening with this switch because I might just need an active pull down or pull up. So right now it's about 0.6 volts, and it goes high when pressed, which is the opposite of what we just changed it to. So if equals high, then it's pressed. So I'm going to just throw a 10K resistor as a pull down on there just to clean this up a little bit. I think 1K, that's close enough. 1K and 10K. What's 9K between friends? So we'll put a 1K resistor to ground. We'll re-upload. Upload. Okay, none. Left, right, up, down. Well, now the button doesn't do anything. Even if I press it, which is weird because it went high when I metered it. Something is screwy here. You know, rather than mess around with a joystick when I could be moving on to writing code for a UI after, you know, a whole evening of saying that's what we would do, I'm just gonna throw another button at it because I have a bunch of little tiny breadboardable buttons, and we'll just pretend that that's the button that's built into the joystick. It's the beauty of prototyping, right? Is like, I don't know, I don't. Here's a thing I don't care to solve right now, so I won't. So let's see. Now I've got to remember which of these pins are permanently connected and which of them are actually switched. So I can never for the life of me remember. So long wires are shorted so the circuit is across the short pads. 3 hours later, yeah, I mean, Chris, when have you, on any of these nights really, when do I ever really stick to the plan? Even, I think I started the night by saying there wasn't one, so I'm feeling all right about how we've gone this evening. So I'm just going to take this switch contact here, this jumper wire. Of course, the Arduino is going to freak out, and I'm going to tie the other side of that switch to ground. Ooh, Chris getting all deep and metaphorical with his pasta making analogies. So if switch is low, then it should be pressed. And switch is indeed pin 12, yeah, okay. All right, so hopefully this gets us to where we need to go with a functional physical interface. Here, I'll put, is that a little easier to see? Not really. Oop. Switch is across the short sides, right? Oh, and I need it. You know what I need is I need it to have a pull-up. which I can do in software. I'll do input, just make this of the input pull-up type. I remember back in the day, because I'm feeling old, when you couldn't just define a pin as an input with a pull-up. You had to say input and then digital write to your input pin in Arduino language to give it a pull-up, because those interfaces are the same. That bit is the same in the registers of the Arduino. Very silly. All right, there we go. Left, right, up, down, none, and button. That's good enough to be getting on with. Okay, there we go. Yes, I don't know what people do out there while they have these things on. I certainly know when I have streams on, I fiddle with things in the background. But yeah, Chris, what do you? If everyone is ever interested in sharing what you are working on while you're noodling on things, or maybe you're just chilling, vibing, and that's cool too. So cool. So I'm going to save this as a separate bit of code because that's a useful test for us to have, and we will say PocketRDM UI. Brainstorm. Let's not call this the final UI yet, but this will be a new piece of code for us to noodle on. So first things first, I think let's have it come up to a splash screen, because I'm vain and I think I would like that. So I am going to steal from, you know what, let's not make it fancier than it has to be. We'll define the thing, we'll say show display, we'll say set text display.set text size 2, display.set cursor 0 0, display.println pocket, display.set cursor. Let's see, 32 is in the center, the bits are 6 wide. So we'll need to go 9 over from center, and it's 32 across, so 23, I think. 23, and we want to go 16 down. Display.println. I think it's just print, actually. Display.print RDM. Let's say this is the splash screen. And we'll have it delay there for now so we can see what's going on. What are people working on? Cookie's working, Cookies. Yes, Cookie's been working on a 3D printed, I think, chain motor, miniature chain motor, 1/12 scale, 1/10 scale if memory serves. I'm super excited to see that. That's been a project that's been like in the back of my mind in the to-do list with the little mini moving lights, but I'm so excited to see what you come up with because I've not even begun to think about that one. Chris is working on updating the SMQ-like button from boxy with something at an angle while trying to reuse old parts instead of starting over. Also pondering the idea of getting new boards and parts to fix a mistake, but also update the thing. Ooh, yeah. How many of those cherry switches do you have on that box there, Chris? Oh, and then I need to, before it goes out, I need to do display. I'm delighted that Josh called me. That really was a spark, put a sparkle in my evening. Josh, I don't know if you're still here with us, but thank you. You gave me a good laugh. Ooh, 26 cherry buttons is a lot. That's also not cheap, I imagine. Oh, you know what I need to do is set text color. I suspect. Ooh, something. I don't like this. I get the beepy boops of the USB device disconnecting in my ear, which I don't love, because it often means that like my cameras are freaking out or something. Let's see here. I get PocketRDM, so I guess I only get 5 characters across. So the characters are natively. I'm getting beeps and I'm getting big USB boops in my ear. It's a bad sign. So they're 12 pixels across in double size mode. Oh yes, I only get 5 characters. That's hilarious. Well, let's do text size 1 then. And I think I should get, if I get 5 characters, I think I have 11 characters in this. So we'll center it up so they're only 8 tall and it's 32. So half of that is 16, so minus 4 is 12. And here we can set cursor. We will, so 9 characters of text is going to be 9 times 6 is 54 pixels, leaving us 5 pixels on either side. And then we'll say version 0.3 because that's what the circuit board is. So we'll say display.print the 0.3 when we get it, and we'll say set cursor. So I have 1, 2, 3, 4 characters of text, which is going to be 24 pixels wide, which leaves us 40 pixels total, which means 20 pixels on either side. And this is going to be 8 pixels tall, so it comes down to 16, so this is going to be at 18. Okay, I think that's right. That's all just a bunch of saying numbers. You know, maybe you tuned in to hear somebody say numbers. Oh, Josh, you certainly made an entrance, as always, yes. I'm now just going to assume that when this phone rings, it's you. Dave is claiming his electronics salon. I'm not sure what that means, Dave, but I like it. Is that your name for your shop and workbench? There it is, PocketRDM, version 0.3. I'm going to move that bottom text down a little bit there. Let's try that again. So, when the device boots up, right, so you bring it into the field, you press a button, it turns on, and when it does, if it doesn't know about any devices, I think the first thing it should ask you to do is just tell you it has no RDM devices on the network, right? So we'll display that for, let's shorten this splash screen because we're going to be looking at it a lot. And we'll take out our testing code here because we can always bring it back. And I'm going to I'm going to start thinking about the state of the devices here, like what sort of mode it's in. I haven't really thought through the architecture of this yet, but that's what we're here to start doing tonight. So I think the first state it's going to be in is a no devices known state. So let's say device state, and actually let's change button state to button states, just to make it a little bit clear what those things are. Device states currently will be just no device known. That'll be our only state, and I will say. I'm going to get rid of this global state. Oh, I guess we can use that global state variable. Int state equals no dev known, right? Because if we don't know any RDM devices, really the only thing we can do is like ask the display to go and discover them. Oh, more people doing things. What are you doing over here? Thomas would be working on his mini mover. Oh, but now that you've blown up your voltage regulator onto computer games, yeah, I know that feeling well. It's like, well, until I can get to Micro Center or Amazon treats me, nothing more we can do on this project. Broke With Me Arms has a project using a Raspberry Pi Zero LEDs and it's an SS1306, has a Q light with OSC. A couple times in tech. Oh, I feel like I saw that in the Tech Theater subreddit. That's very cool. What are you using? Oh, OSC. What are you using as your Q light control source that's sending OSC? Do you have another Pi-based solution for that? So let's see. In our control loop here, we'll say, so we're gonna have to have sort of a number of things, sort of master modes of this menu, only some of which should be available in some states. You know what I could do is I could say int dev known equals 0. And let's get rid of this enum for now. I'm kind of just noodling about with like how we track the state of this thing and how we build a state machine out of it. So really what we'll say here is if dev known is less than or equal to 0, because maybe sometimes it's negative, it shouldn't be, Then display state, show display, and let's say, so we've got 5 big characters to say something with. Maybe discover is the way to go. And maybe the lower text is, we've got 11 characters here to say something. Must please discover devs. That's probably too many characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Please discover is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That might still be too much. Because we don't have any control logic yet, we'll just have it delay, have a say, let's do that over and over again. This is a place to start. Oh, show display. Oh, and then no lower right text. There we go. Ah, broke both, yes. Using a Raspberry Pi Zero with a few LEDs. Mine's a Raspberry Pi with QLC Plus and some ESP receivers, says Chris. That's pretty cool. As I fix my typos off screen here. Brokewood has a Stream Deck from Elgato. Ooh, I love the Stream Deck. That's what we're using this evening. Thanks to Nate there. Thank you. And key switches to make keypads. Yeah, that's fair. Fortune OSC library and added TCP support. Oh, that's cool. With Discovery. Ooh, also cool. Discover. Please discover. It's a little silly. Please discover PLS space DISCOV. Like 10 characters in that bottom line at that text size. You know, they probably don't need to say discover twice. We could say press enter. That's 11 characters. Press but. Press but. We'll need to kind of come up with some better language around what it means to like, what the like verb for pressing the button is. Discovery on network for QLights is really, that's quite clever, broke both. That's like, you know, like, what am I trying to say? Relieves the need for a certain amount of configuration, which is always helpful as an end user. Well, that's very silly. We're not going to leave it as press but I do kind of like it. Oh, BUTN is yeah, we'll leave, BUTN will leave for now. I'm thinking maybe later on, like press is going to become like a lot more overhead in terms of text amount. It probably just wants to be like a summary word for what pressing the button will do. All right, so now we need to, so what I'm going to need to do is fake some device discovery, right? So I'm going to say void discover devices, because I haven't, as I say, completed, I'll say discover devices, bool, discover all. So when I write some code that like takes up some arbitrary amount of time and like sets some variables internally, and ultimately will replace this sort of dummy function with the actual data from the RDM, the JDMX RDM library when it's done. So we will say, let's see, what was my variable for how many devices I know? This is a kludgy way to do things. Dev known equals 3. Dev IDs. Let's see. I always get this syntax wrong. Let's see. We'll define an array to hold the IDs, although, to be fair, those IDs are going to be 48 bits long. Can we do a long? How many bits is that? Is that 64? In C++, long is a 64-bit type? At least 64 bits. Okay, so yeah, so we'll do an array of long, if it'll let us. Yeah, And that will hold our 48-bit RDM IDs. So for the time being, every time we discover devices, I'm just going to manually set the first. I'm going to say that we're going to discover 3 devices every time, and they have these set IDs. And of course, we'll replace this with actual code later. We'll say dev IDs 0 equals. Will it let me do generic hex here? Let's find out. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, A, B. Yeah, it will. Arbitrarily sized hex. That's great. That'll make this easier. We'll say OX 2, 3, 4, 5, 6, 7, 8, 9, 0, A, B, C. And dev IDs. This is maybe not the optimal way to store these because an RDM ID actually has 2 sort of separate parts. It has a 16-bit manufacturer ID. No, sorry, I got that wrong. 4 bits, 16-bit manufacturer ID followed by a 32-bit device ID. So as a manufacturer, you apply to the ESTA committee for an RDM ID, and that's the same across all of your devices that you ever manufacture. And then each individual device has a globally unique ID, a 32-bit ID that you assign to it in your factory. So I have an RDM ID. Ooh, yes, Dave, push is better than press. I would agree with that. Change that now. Ooh, need a little hydration. This is what happens when you ramble for 2.5 hours before you get to the thing you were in theory going to do. All right, so now we have our devices known. We're going to find devices. So I can say if dev ID is less than this, show device ID. And actually what I could say is while get joystick state is not equal to switch pressed loop, just hang out. And then when it is pressed, show display. I probably need some more variation in like this. I'm quickly realizing this factor, which is nice and clear, is a little bit limiting. So what I think I'm going to do, because what I want to say here is like discovering devices, please wait. So maybe I'll just do it manually for now. Or we'll put it in a little cheapy little sub function. So we'll say void please show discovering. Just to keep things a little bit cleaner up in the main loop, we'll say display dot clear display, display dot set text size 1, which is its sort of default size. Characters are 8 pixels tall by 6 pixels wide. We'll set cursor to pixels x0 y0. Oops, that's display dot set cursor. Display dot print discover disking. Can I print line? I think I can. That'll automatically increment. Display dot print line devices. Display dot print line, please. Display dot print line, wait. Then we're going to do discover devices. That discover devices function that we wrote that doesn't really do anything now, but I'm actually going to have it delay 2.5 seconds just to ooh, a character that implies waiting. Yeah, Thomas, I like that. Well, let's see. What's the code point for something fun? Code page. I keep saying code page. Code point. CP437 table. Oh man, my computer is freaking out about something. There we go. So here we go. What do we have that could imply wait? We have lots of these like maze and window drawing here. Like show that a little bit better. I could custom print a thing too. I could do this as a bitmap, but I don't think I have a built-in character that'll do it. I'm gonna make our discover devices. I'm just getting like USB beeps and boops in my ear because it's something is freaking out. It could be the power supply to that USB hub is failing, because it's a powered USB port, but everything still seems to be working, weirdly enough. All right, well, we'll see how that goes. I'm gonna have this discover device thing arbitrarily delay a few seconds, like it was actually going out into the universe and doing something. Oh man, what is it freaking out about? I don't know, but everything is literally still plugged in and working. So I guess I'm not gonna sweat it too much until stuff starts falling off. Yeah, I don't know. How bizarre. So where were we? We were PocketRDM display. Here, show discovering. Please wait. Then discover devices probably wants to be back up in the main code. So we'll say while it's not pressed, show discovering, and then discover devices, and then we'll have it show the discovered devices. We'll have it say, let's do a new thing. Actually, here, before we get too far, let's make sure what we have so far worked. Oh, discover devices. Oh, yes, so I snuck an argument into the discover devices code here because I know that later on I'm going to want the ability to specify when calling the display, like find devices code, whether I want it to unmute the already known devices first, or whether it should, only find new devices. Basically, should it discover everything, or should it just send a general, like, hey, if I haven't muted you before as a controller? I guess, I don't know how familiar people are with RDM, but as we're sort of writing basic display code here, maybe it's a good time to talk about it. Let me press the button. Press the button. Something is not right there. I wonder if it's getting hung up in, oh no, interesting. So if the device is known less than or equal to 0, show display, which it clearly did, while get joystick state not equal to switch pressed. Loop. Show discovering. Oh, you know what I didn't do? Which I always forget. I didn't do display.display. Every darn time. The way RDM discovery works, or one of the ways that the spec suggests that you discover RDM devices, right, is every device has, as I mentioned, a 48-bit unique in the world ID, a globally unique ID consisting of 16 bits of your manufacturer's code and 32 bits of your device code that you set at the factory. It's unique to every device you as a manufacturer will ever make. So the way that the spec recommends that a controller that you've plopped in the network find devices, disking devices, please wait. Now wait 2.5 seconds, and then it won't do anything else, because as far as we've gotten. Says you should do a binary search through those GUIDs for devices, and so basically it says, if you want to discover every device on the network, you send a global unmute all message. Say, okay, everyone free for all. Anyone can talk when I say so. Any device with a globally unique ID between address 0 and 2 to the 48th minus 1, the highest one there is, say hello. And most likely, if there are multiple devices on the network, they will all try and talk at once. And that the response, the discovery response method message is formatted in such a way that the collisions between two simultaneous discovery response messages are unlikely to themselves combine and overlap in such a way that it looks like a valid response, it probably will look like garbage. And so the controller throws out, okay, everyone, any device in the network, come back to me now. And it probably sees garbage. And if it does, it says, okay, I probably have 2 devices in the network trying to talk at the same time. Let's cut the space in half. Anything anything in the first half of my search space only, not in the second half, only in the first half, come back now. If it still gets garbage, it says, okay, anything in the first half of that space, come back now. And it does this until it gets a clear and crisp response, but it's okay, I only have 1 device in some small subset of my range. It's okay, I've got your information, I know you exist, I've got your data. Now I'm sending it directly to that 1 device, a mute message. Say, okay, don't respond to any further discovery messages, you're muted. All right, and now it goes back up a step. It's okay, I know that this was the only device in this range, anyone in this range again. If it gets garbage, it narrows down that range until it just has 1 to respond. So it basically does a depth first search, a binary search, until it finds the unique devices in unique places in this address range, and then accumulates a list of them. And because a single controller on a single RS-45 DMX RDM line is probably only gonna have to deal with like 20 some odd devices on a single DMX physical hardware chain, it doesn't take that long to bifurcate that search space until you're pretty confident that you found all the devices on it. Yeah, no, it's a totally good idea to do a bitmap on these things. Maybe let's get a couple more steps into the UI, just because I feel like we haven't gotten very far tonight. But then, yeah, we'll go back and put a bitmap in, because that'll be a good example to do, and some good practice for me, frankly, working in this library with bitmaps. So we've discovered our devices, and once we have, it would be good to tell the user how many devices that they found. So we will just, you know what we'll do here is, rather than writing a whole new function, we'll say show display string devs. What did I say? Dev known, which is not a great. I should say num dev. Let's just change that. We'll just do a find replace. We'll say dev. Find replace dev known with num devs. That makes more sense to me. Replace all. And I will say, we'll just print out to the screen. We'll say how many devs we found. Just so the user knows, and then we'll wait a couple seconds just as like a little sanity check. So if you plug it in, it's like, hey, I found 5 devices, and you think there should be, 15 on a chain. You're like, well, something's gone wrong. Man, my computer is freaking out about USB something or other. How bizarre. All right, PocketRDM, discover, press button, discovering devices. Yeah, a little spinning symbol here would be nice. 3 devices found, nice. All right, well, that's as far as we've gotten, but that looks pretty good. So once we've done that, then the user should have a few, I think, and this is me brainstorming, so pitch in any ideas you have. I think the user should have, let's start with 2 options, right? Discover, which could be discover all or discover additional, and address, right? So once we've discovered things, we have more options. So outside of this if num devs loop, we'll say else here, and basically each of those is going to be a static display. And I could probably reuse the code for my discover function here. To be the sort of menu option for discover. So when I will say, I'm gonna need an enum here, I'm gonna need a state. I'm gonna say enum menu locations, discover, and address will be my 2 that I start with. I will say my menu loc equals discover to start with. And now I can have it sort of display one of a number of menu options based on that variable, which I'll change when the user moves their joystick around. So we'll say switch menu loc. One thing we'll have to sort of contend with is like it does take a sort of finite amount of time to push data to the screen. So I really only want to be pushing data to it when things change. So I have to sort of account for that. Switch case discover. And break. This is not a great, as I'm typing this out, it's not a terrific way to organize this code because it's going to kind of break up the like the display and the behavior of things. Like it'd be nice if the code that said like, okay, it's going to show this on the screen, and when you press these buttons, these things happen. But we'll see if that's surmountable. I guess I'll use a character here just to remind the user that they can use the left or right button to move left and right. So character 29 on this code page is the sort of left-right arrows. Maybe I'll use a left and a right arrow. So 26 is right and 27 is left. Char 27 and char 26. And we'll do the same, char 27. And char 26. And upload that, we'll see how that looks. Oh, right, and because it's a character, I have to explicitly cast it to a string. For a reason that I don't fully understand, I'll be honest, but string, character 27, string, I mean, I assume there is a decent reason. And characters are not strings, and strings are not just arrays of characters in this particular world, but that seems like an implicit conversion would be fine in this case, but maybe there's something I'm missing. Now I'm just being cranky. What I really need is a function that waits for the button state to change. That's because a lot of this is just going to be reactive based on button press. There we go. Discover, push button, I do. It discovers devices, 3 devices found. And now we have, it says discover. Actually, it's pretty good. If I had a little indicator here that said like enter or press, that would like indicate that you could do a thing there. Maybe it's in our string function here that says enter plus enter. Oops. We'll see how that looks, and then we'll deal with some button input. In fact, maybe we can start writing that now. So I think what we want to do is int wait for input change. That's going to basically put us in a holding loop until something happens. So we'll say int current input state equals what? Is the previous state. I guess previous input state equals none. While get, let's see. Int current input. This is, I'm not sure this is exactly the way I will finish up writing this, but I'll say current input state equals none, while previous input state equals current input state, current input state equals get joystick state. This was why I was sort of thinking about breaking up this get joystick state into a separate function. So let's reuse that code here, and I will say return current input state. So it's not really necessary to have this previous input explicitly declared because it could be none. I'm just thinking we might need to like wait with a button pressed sometime or something. But and I will say button, let's see, int input equals wait, what do I call that? Wait for input change. Wait for input change. And so yeah, so this is the point. This is sort of what I was talking about, like that the inputs and the display logic are kind of separated from each other in a way that I don't love, because it'd be like currently I'm in this state. Oh, that does look pretty good. Yeah, even though I do left and right. I think up and down will be nice when we're like setting a number address. Like I can see it's like incrementing through like the digits and then taking them up and down. I put one more space in there or tweak that later, but that seems like more fiddly than we need to do now. So now what I want to do is like when I go left and right, I want to toggle between different menu options. I would say, let's see. And I could say, if input equals left or input equals right. Let's see, if input equals left, menu loc minus equals, let's see, equals, minus equals 1. If menu loc is less than 0, menu loc equals, can I do a length of an enum? I don't know, C++, length of enum. Thanks, Stack Overflow. Various type-safe enum techniques. Max. Ugh, this is all kludgy. Well, that's all right. We'll say num menu locations equals 2. We'll just track it manually. In fact, we'll make it const so we can't change it. We'll say const int num menu locations equals 2. And we will say if we've tried to scroll lower than our lowest menu input equals num menu locations minus 1. Else if input equals right, menu location equals menu location plus 1 mod num menu locations. Okay. That, I think, should get us to a scrollable menu. String show display was not declared in the scope. I absolutely did. That probably means I'm missing a, yes, this else statement is missing. Yes, it's missing a big old parentheses that, and then this should all be indented. All right, let's try compiling that again. No match for the minus equals operator. Do I really, what? Am I crazy? Oh, because I'm using an enum. As I can't index through an enum. Ah, that's a bummer. So Thomas, I don't if you're still if you're not docking two spaceships right this moment. Here's a good point that I'd forgotten. So an enum treats the possible values that you reference as numbers under the hood, but it's not an array. So I can't reference these by number. So I tried to like use a number to address, be like, oh, I'm in state 0, then I add 1 to it, so I'm in state 1. But because it was an enum, I couldn't actually do that. So if I want to do that, and I do, because it moving through these states as in sequence will be really nice. But that's such a bummer. Can I do a valued enum? Maybe. Let's find out. Enumerator equals const expression. Ooh, maybe I can. Discover equals 0, address equals 1, and call this an enum. Let's see if that compiles. Operand types are menu locations and int. Yeah, I don't know that you're supposed to int n equals blue. Implicitly converted to integral types. Now you're just watching me learn how enums work in C++17 on stream, which I'm sure is what you all tuned in for. But we're back to sort of the fiddle. I don't know if this is noodling anymore. This is fiddling, I would call this. Names of an unscoped enum be omitted. X direction left. No. I don't want to scope to. I want something I can move through by index. Yeah. All right. Well, that's a shame. Let's see. Int many locations. I guess honestly, I don't then need an enum. I just need a total quantity and an index for where I currently am. About adding the sauce to the noodles, this is more like trying to discover what the sauce recipe is, I think. Now it's gonna throw up on me. Oh, but I could let's see, int. I could re-implement this, const int. I'm sure there is a better way to do this, but here we are. Yeah, I tried to be clever, and now it's getting me. But this might have not been as awful of a kludge as I had previously imagined. Yeah, yeah, Chris, we've gotten deep into the food-based metaphors this evening. Which is good. When side story as we're uploading code, this afternoon my wonderful wife Mary, who you've now all seen, was like, "Hey, there's a football game on. Do you want to order pizza and wings and just eat junk food this afternoon and like watch the football game?" She's the best. I found 3 devices, shocker. So now, oop. Well, so I'm certainly switching between modes there, but a little faster than I meant to. So not the most usable. Okay, well this is good. So let's see. So what's happening, of course, is we're showing our state, then we're waiting for input to not be centered. We're actually not waiting for it to change. So what I'm going to do is move my declaration of my previous input state to make that a global. declare it all the way up at the top here. And I will then, instead of waiting for my input to not be centered, I will wait for it to change. And that should require I think, we'll see, maybe I've got this wrong. I think this will require the stick to go back to center before it can move left or right. And it also wasn't moving to the left particularly well, and I'm not 100% sure why that was. But we'll see. PocketRDM, push button, discovering devices, please wait. 3 devices found, who would have thought it? Oop, yeah. All right, so yeah, so right works too well, left doesn't work at all. That's not a great trade, huh? A PS4 controller controlling a moving light. Ooh, that's fun. Let's see here. Oh, and then at the end here, I will need to say, I have to update that previous input. Say previous input state equals current input state. Now, why isn't left working? BOI greater than 950, I would have thought. I guess I didn't need to do these analog reads multiple times, huh? Like I said, I created these pos x and pos y variables here, and I didn't even use them. All right, let's try that. I don't know if y'all can hear the tunes. I've turned them quite down, but the stream tunes are playing in my ears, and that gives me joy. So if you can hear them, great. If you can't hear them, then I apologize. Or turn your volume up. But then you get these pipes just sort of deeper into your brain, and I don't know. That's up to you. There we go. Yeah, there we go. So yeah, so weirdly, right works, left does not. I'm gonna quickly just make sure it's not a hardware issue. I'm gonna re-upload that test code we wrote that just displays on the screen what the joystick is doing. Let's see. Let's re-upload that. Oh, good. Tunes are good for working. Like when I'm like deep in a coding zone, I either put on, well, sometimes I put on like, you know, a cheerful guy in a sweater talking about a project sort of very slowly. It's always a good option. Or I do like, this is not really my jam at all. Yeah, left works there. Something has gone wrong between these two pieces of code. Maybe there's a problem in my switch statement or something. Or like really heavy like synth, like 80s synth music. If pos y is greater than 950, return left. That's the same thing I'm doing in this test, right? VRY is greater than 950, state equals left. Let's see. If input equals left, maybe it's something here. Manipulation plus equals. Oh, right, because I changed that to +1 instead of -1. Because I was having issues with the enum not accepting a plus command. Blah. Can't listen to podcasts anymore talk when I'm programming. Yeah, it's funny. I was working doing some spreadsheet work for a local theater awards committee that I'm a part of last night. Doesn't really matter, but I was like trying to type up a kind of important acknowledgement of like the place of this prize in the world that exists this year. And my wife and I were both doing computer work on the couch while we had the next Karate Kid film on in the background, which I had never seen. And I, not the Jeff Awards actually, Chris. But I at one point had to be like, hey, can we actually pause this for like 10 minutes? Because I can't wrap my mind around how to like formulate like accurate and important nuanced text while like Mr. Miyagi is like talking about crane kicks in the background. Like the words just can't. I'm with you, broke both my arms. Like there's just something like the there's only one word part of the brain that can work at a time. Wait, well, so now we're scrolling through menu options, which is good. Discover, address. Maybe let's add one more called like config. And that should be easy enough. We'll say our state 2 is equal to config. And we'll say const int config. Oh, I can't use the configure. Equals 2. There are now 3 menu locations. Just to sort of prove that we can add menu options here. Oh, I should add a break. And case configure. And when we are in the configure mode, and maybe this is for like setting up personalities or something. I'm not 100% sure that's going to be a valuable thing to do on a display this small. But this will be more of a validation of the UI, if nothing else. All right, push button, discovering devices, 3 devices found, discover, address, and configure. Yeah, there we go. Okay, so now I can like scroll through and like select what I want to do. And of course, pressing the button doesn't actually do anything. I guess pressing up and down won't do anything in this mode either. Probably just enter. I mean, honestly, yeah. All right, so left and right and enter. All right, so now let's get to actually do something. So I think the easiest one, because we already have functionality for it, is display. So we've waited for input change, and out of this menu here, we'll say else if input equals switch pressed, then. So this is where I think we're going to need an enum to be like, are we in the menu mode or are we in like one of our sub modes? Like, are we menu? Are we in the discover setup? Are we in the addressing setup? Are we in the configuration sort of setup? So I'm going to say enum, what do I want to call this? Active modes. And that's going to be menu, discover, address. So what I'm seeing here is I'm sort of redefining the same thing twice, right? I'm putting an enum in here, and I have these constants for the menu that I'm iterating through, which I don't love. So instead of defining things twice, what I think I'm going to do is instead, and we'll probably have to change this later, but I'm going to try a Boolean that's defines whether we are in the menu or sort of in an active sub mode. What's a good term for that? In active sub mode. I hate that variable name. In menu. How about in menu equals true? We'll have an in menu variable. So now if we're down here, we'll wrap this whole thing up in, we'll say if in menu, then this is what you should display. In fact, we should probably switch, oh no, if in menu, we'll do all of this menu behavior that we have. Let's make sure that that parentheses lines up, yes. An int for each mode. Yeah, it's kind of what I'm going to end up doing here, Thomas, is like I have an int, I have a discover mode, I have an address mode, I have a configure mode, and it's going to tell me like where in the menu I am, and then when I'm in one of these sub modes and I'm not in the menu, that variable is going to tell me like which of the sub modes I'm in. So I'm going to say, so if I press the button, I'm going to say in menu equals false. All right, so now this should be, if we're not in the menu, we'll say else. This is not in menu. We will switch menu location. We're actually going to reuse that variable. And we'll say case discover. Let's just line up our cases here. Break, case address, break, case configure break. Okay, so if we're in the Discover menu, what I really want is to do this again, is like show discover, push button, show discovering, show discovered. So I could just copy and paste that, but really this is just the discover action. So let's put that into its own little bit of code. Let's say, we'll say void discover action. And we'll just put all that into its own bit of code so we can reuse it. So the first time, before we have no devices that we know about, that's the only thing we're allowed to do, because it doesn't really make sense to allow the user to like configure or address things while there's nothing there. But we can reuse that code later. Had to get a working prototype and fix it up later while it's worthwhile. Yeah, it's kind of, especially since like the whole goal tonight was to work on the UI. It's like if it's exactly clean, who really cares? But so now, if we're not in the menu, we're in the Discover section, and we will say Discover action and break. Oh, this is not right. What did I say here? This is case discover. Discover action and break. Now, what should be different here, I may not actually be able to reuse this exactly, because the first time, the only thing that was allowed was press enter to discover devices. But this time, what I want to do is press enter to discover devices, or press left to go back or something. So maybe we'll just copy and paste for now and see how that goes for us. So we'll say show display. So here's what we'll do. We'll say push button, and we will say all. Let's see. Let's discover. We're in the Discover menu, and we want to say, do we want to discover all? I need like a sub choice. So let's make a modification to our show display function that has some sub choices to it. So we'll say void show display with sub string big string lower left string lower right. We'll do show display big lower left, not big font lower right, not big font, so false false, and lower right and string sub. So I will say, steal a little bit of code from up here, the self-centering part. Width is so show sub. So we'll set text size back to 1. We'll set text color back to white. And we will set the cursor to, so the big one takes up 16 pixels. So we'll start at 17 pixels. The subtext dot length, let's see, the middle is going to be 32 minus subtext dot length times 3. So that should self-center that, and this should all be display dot set text size, display dot text color, display dot set cursor, and display.print sub. Okay, so now when we're in our discovery menu and we go left and right, we will say, let's see, string modes equals all and new. Mode index equals 0. Show display 0, 0, and our sub is going to be modes mode index. I think this will run as is. It's not going to do anything with that index yet, but oh, can I not do? Was that right? Yes. Bum, 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 bum. I explicitly cast this to a string. Ah, what is happening here? String big, string lower left, string lower right, string sub. Can I make this a... No, that shouldn't matter. If I do this explicitly? Constar 5, constar 1, constar 1, constar 1. Oh, you know what it is? It's not show display, it's show display with sub. Is the name of that function. Show display with sub. And we'll do modes, mode index. And we need a semicolon. It says who? How about disk mode index? Because we've already used mode index as a variable somewhere in our code. Oh, that wasn't the error. Something crosses. Oh. This should be white. I'm probably missing a parentheses is what that error is trying to tell me. Yes, what? Crosses initialization of int disk mode index. Yeah, working in the Arduino IDE is not the best. I'm used to, when I do all my Python work in VS Code, and that just makes my life just so much happier. Let's see, what is... What is this trying to tell me? Crosses initialization. String modes. Oh, if I have the wrong bracket types? Is that what this is trying to tell me? No, it should, am I crazy? Oh man. I'm, no, I'm not crazy. I guess maybe I can't do string arrays. Maybe this is because it's char. Because it's treating it as char arrays. Is that what this is? No. Well, here, let's, for the sake of carrying on. Will VS Code do an Arduino upload, Chris? I mean, if it does, I've never, to be honest, I've never looked into it. I just assumed it wouldn't work great. But if it does, I will switch. Oh, heck yeah. There's a plugin for it? Oh, heck yeah. What have I been doing? What have I been thinking? Well, I'm not going to try and switch right now. That seems like a recipe for things going poorly. But by the next time you see me, we will have abandoned the Arduino IDE to the whole. Discover, address config. So discover. Ooh. So, okay, so what's happening here? So, when we're not in the menu, oh, because we're, so I think what's happening is we're jumping into this sub-menu, and then we're not waiting for the switch is still pressed from entering the sub-menu. So we're not, like, the switch is still pressed at that exact moment. And so, of course, it's like we're entering the sub-menu, and then that button press is still, like, causing it to, like, take the action of that sub-menu immediately. Longest stream yet? Yeah, I think so, Chris. I mean, I think we've entered, like, the slightly lower energy phase of things, right? Because, like, coding is, you know, we're vibing a little bit more now. We're doing good work, but kind of noodling. Fiddling? What did we say this was? This is the fiddle time. So, like, I feel like we're kind of, like, doing you know, 2.5 hours of, like, problem solving and things, and now we're just kind of like fadoodle, and we'll do, like, we'll get to a good point and we'll call it for the evening at some point. But yeah, I mean, I think it's certainly my longest stream. We're getting on to 4 hours now or so. Someday I'll do one of those, like, 24-hour streams that is so popular, but not tonight. All right, well, okay, so now we're in the discovery menu, and we can discover devices again. But our sub display is not showing up, which I thought would be a nice touch. Where is our to show with sub? We show it. Set text as 1. Set cursor to. I've mixed up my x and y values. Well, that's not going to help me out any. My x value should be this, and my y. So we were putting the new text off the bottom of the screen. Because what I want is What I want is a mode where, like, when we're in this discover menu, we should be able to go left and right to select whether we want to discover all devices or only new devices, and it'd be nice to have that little text on the screen here. And then maybe down is the key for back or something. Enter. Oh, still no. What gives? Set text size, set text color, set cursor. Set text color white, set color 1. Set cursor should be 32 minus half the length of the string in pixels, and the y value should be 17. That doesn't seem unreasonable. But let's just double check here. So when I'm printing the lower left, we start at 24. To actually, display.display. Gotta push the thing out of the buffer every ding dang time. This is part of the reason why I write these, like, sub functions, like, to, if I'm gonna put something on the screen, I put it in a separate function, because then I only have to do this once, and I can reuse that function that takes care of all these things that I keep forgetting over and over again for all the other things I want that display function to do. Discovering devices. I wonder how many. It's 3. All right, discover, and it says all. Nice. And we discover when we go back. So I don't have the back functionality working yet, but that's okay. So we're in our discover function here. We wait for a button press. So discovering false, delay 200. And then what I really want is not delay for switch press. What I want to use is that wait for input change. Input equals wait for, did I already put input in this scope? I did. So I'll say input equals wait for input change. And then I will switch input again. Have to, man, this is spaghetti code. It means the spaghetti turned out to be a good metaphor for this evening because we're getting really spaghetti-y. We'll say case switch pressed, and in that case we want to do our discovery. If we're in this menu and we do case is down, we will say, oh, I'm getting a call. Hello. Oh, it's the wife. Hello. Yeah, you know, you're not. No, I'm good. You're not the only person. The lovely Chris Wick was just pointing out this is probably the longest stream yet. I don't see how it couldn't be. I'm good. I got water. I finished my beer. We're chugging along. No, Chris, the wife says she's not saying it's time to stop, but she was offering if I needed like food or water or anything. Oh, or if I need any other kind of break. Thanks, hon. I appreciate you. Love you too. Bye. Thomas, you make a very good point. Well, you make two very good points. One, Mary is the best. Second, yeah, I thought I had configured my my VoIP service that services these two phones to go straight to voicemail after 10 p.m. local time, and it's almost 11 here. So that's actually good to know, because that's quite a thing. Why don't we get this back functionality working that we can so we know we can get into a menu, we can do a thing, we can get back into the menu. And then we might have to call it because we are going on 4 hours here, and that, at some point the code is going to get more and more and more spaghetti, and that's just what it's gonna be, and no one's gonna like that. So let's see here. Case down. So if we're in here, we want to say in menu equals true, and that might just be it. Break. Yeah, I think that will take us back out of the menu. And back to the menu, I should say. Input was not declared. Oh, I guess I did not. I guess that was not in the same scope. All right, so let's upload. I'm getting the same initialization error. What is this? Int input. What is this error message telling me? Crosses initialization for int input. It's telling me it's initializing that. So I thought the input, I guess it's not in the same scope than the other if statement. Wow. Case discover. Switch menu location. Wait for menu. Discover. show this while joystick state equals nothing, do nothing. Input equals wait for input change. Switch. Input. Do I not, am I, maybe, oh, no, that's, yeah, should have parentheses here. I'm gonna do that thing where I just Google this error message. Never doubt the power of Google. Well, I mean, always doubt the power of Google. It's like, what is this? I don't know what this error is telling me. Oh. Switch is not. Ugh. Okay. Well, maybe I need to. This is gonna be. Wow, you wanted to see it? Did you want to see a kludge to end the night? I'm just gonna start dropping global variables in here. That's gonna fix it. Yep, sure did. Yeah. So okay. So what I think I just learned, and maybe this will be useful to somebody else, and maybe here, maybe my pain can be your gain. I was getting this error that said, you know, crosses initialization of int so-and-so inside of my switch statements. And a brief perusal of Stack Overflow just then implied to me, here, I'll show you, that so the switch statement, you know, switching between various cases of things, seems like it's operating a lot like goto statements. It's jumping between sections of code. And much like a goto, is not allowed to jump over the initialization of any variables, because then variables after the goto might be uninitialized, and we can't have that. So to correct that, I just moved that initialization that it would have to have jumped over back to be a global variable in my entire code. That input variable, which was an int I was declaring locally, is now a global variable, and I'll suffer the consequences for that later. Discovering devices, devs equals 3. I can move between various parts of the menu. If I go into the Discover menu and I hit down, oh no! I can discover devices. Found 3 devices, amazing. But now I can't get back. That's the one, that's where I was hoping we could leave us, is how do we get back out of our menu? So if we're in our menu and we say switch input case pressed, in menu equals true. Now, if in menu equals true, and we exit this case, and we come back up to the top of our loop, and we say if in menu, switch menu location, case discover, show display discover. And then, you know what I should do is while get I'm gonna end up I should really wrap this into a separate code. So what I think is happening is I'm pressing a thing and then immediately entering another state, and my input is still pressed, and so it's taking some action in that new state that I do not intend for it to be. So I'm putting in this if get joystick state is not equal to none, just hold here, wait, don't go anywhere, and then when the inputs are neutral, you can move on to displaying the new thing. Actually, it's not exactly the behavior I want, but it's going to get us there for this evening, I think. Oh, no. Why are you not? All right, so we still can discover, right? Yes, okay, that's good. Show switching process case down. In menu equals true. So why is it not going back to the menu when this happens is what I'm trying to figure out. Interestingly, going up seems to do something. Maybe I have my up and down backward, but even if I do, why? Let's see, greater than 950 is down? According to my notes, that's correct. What else is happening here? Void luminous. If in menu, and we are, switch menu location, and then we should just go straight to show display. And when we do that, just make sure we're not like printing everything in black text or something. We clear. Black on white. Lemon White Claw. Ooh, yeah. Bubble time. Nice. I'm bewildered. I don't know if these nested switch statements are all that kosher. I think they're okay. In menu equals false. Case down. That's just in case it's the down that's throwing us off. Let's make it case left. The left button will take us back out of the menu. Maybe that's the thing. Maybe it's an input problem. All in all, I'm happy with how things are going. I mean, clearly this is the fiddly part of the of the night. I'm also really pleased with how well this camera's holding up. To be fairly frank, like I was like, oh, well, I'll talk about the thing. I was like, can I actually get that little tiny display on camera? It turns out, yeah, actually, like it's working pretty well. Discover left. Hey, there we go. Like that. So something with my down positioning was being strange there, but I can go into discover. I can make it discover, and then I can go back to the menu. Can move through things, and I could go into an address mode, and I could address things, or what have you. Broke both. So the one that's on the tabletop here is a Sony A5100 mirrorless. I just have like the basic lens that it comes with, which is like a I don't even remember off the top of my head, a 40 to 105 zoom. It's 16 to 50, but it's not a full frame camera, so I gather that those are different equivalencies. 3.5 to 5.6, 16 to 50 stock lens. And the autofocus is sometimes a little bit weird on it, but like I mean, it's also like I think 10 inches above the work surface, which is about as close as you can get, and still have it focused decently. But so far, it's holding up all right. It's been a while since we've come in anything this close on the stream, and I'm feeling good about that. Wow, 4 hours in, huh? The addressing functionality is really what I thought we might do tonight, but I just don't know that I have the stamina for it, or do I? Hang on. Let's see. In menu equals false. Switch case discover. Case address. Let's see. Brokewith has Panasonic G85 with a 1260, ooh, and a 25mm 1.7. Make a build video. Yeah, I mean, I'll tell you what I do a lot of the time if I'm trying to film stuff. You'll see on the channel, I've done a few like recorded videos, and I just get really precious about them, and I over edit them and various things. What I like to do, rather than recording directly onto the camera, although that would be higher resolution, is I use the capture device that I use for these streams, and I use OBS to just record everything straight to the computer, and then it's just all there. So as long as I'm recording within, like, proximity of the workbench, which I always am, I don't have to worry about, like, getting everything off the SD card, onto the computer, and I can kind of label things in the computer as I go. I don't know, that just seems to be a workflow that works for me. But yeah, if you do a build video, let me know. I want to see. Ooh, yeah, the mini pros are nice. I'm using a just a cam link, one of the little USB ones that just like the dongle that just into your USB 3 port. The Mini Pros are super super cute. Yeah, let's see. Do I have it in me to get this addressing up tonight? I'm gonna do the very basics. I'm gonna do the very very basics. We're not, and that's where we'll call it. So we'll say address. If we're in addressing mode, we'll show the words. Let's see. So the user will have to select a device. And we're just gonna fake it for now. One thing that I think would be a classy feature that I'm not going to implement tonight, is, so, you have your little display, you enter address mode, and it says, okay, select a device, and you're like, okay, device 1, device 2, device 3, you move through them. And as you're moving between devices to address, every time you change device number, and the device number will just be like a little local index of like the order it found them in, basically, it's an arbitrary order. But when you get to a device, it sends the identify instruction to the light, which usually makes it like flash slowly. So as you're scrolling through, you can be like, is it that one? Is it that one? Is it that one? Oh, that's the light I wanted to readdress, and you can get to it. And so when you get to a light in your scrolling through, it will send the identify command. When you scroll away from that light to the next one, it will send the stop identifying command to the previous light and the yes please identify command to the current light, just to make it really easy to see which light you're working with. I don't know, that's I think a classy thing. Again, beyond the scope of this evening, but so if the switch is switch pressed, we'd go into, honestly, we're just going to only allow us to get back to the main menu for now. Let's upload that. Didn't know identify was just a signal. Yeah, so identify is just a, here, I'll show you. I have my binders of ESTA specs just back here. This is more than you asked for, I'm sure, Cookie, but, maybe the last 4 hours were more than you've asked for. So here in the big book of RDM things, get up there. Which is ESTA spec 1.20, which is available for free online, which is super cool, at the ESTA's website. You get the list of all of the various, how RDM works, basically. But if we go back to the various allowed messages, let's see here if I can find, yeah, so on page 93 of the spec, we will find RDM message for get set identify device. Parameters used to physically identify the device represented by the user ID. Responder shall physically identify itself using a visible or audible action, for example, strobing a light or outputting fog. I think that's a bad idea personally, but here we are. So yeah, so you send this particular RDM message to a particular device with the get command, the PID, which is the protocol ID, or the command ID is really the critical data here. And back in the index here, you get all of the actual values for the identify for all of the messages, really. Let's see here. Where is, yeah, so identify device is hex 1000. So you'd send an RDM message with command 000. If you send the get version of this command, you don't have to present any additional data. And it will send you, it's required to send you a response, which is very similar. We'll send you an acknowledgement type. The command type will be get command response, which says this is a message that was coming from a command that you sent me, and it will indicate whether it was on or off currently. You can also just get the state. Almost all of these messages that you can send are either, set the state, like I want you to become this thing, or just get your present state, like you can get or set the power state of the device. You can get or set the lamp hours, and all of this is, right, of course, device specific, like whether it's actually implemented all of these PIDs. For example, like get and set preset playback. If your device doesn't have like built-in presets in them, this obviously is not going to do anything. There is a subset of the commands that all devices per the spec are required to implement, and that's in Appendix A here. So every device is required to correctly implement the discover unique branch, mute and unmute. That's like the commands for that discovery method, how a controller can find it's on its network. If you're responding to any additional messages between the basic sets, you're required to implement this command that tells your controller what those parameters are, which is pretty classy. Basic device info command, the software version label command, so your controller can be like, oh, it's running software version 0.96 and could take appropriate actions. You're required to implement the DMX start. This is an awful way to show a document, huh? The DMX start address command if your device has a DMX address. Oh, and identify is a required command, right? So every device must identify itself. And then all this other stuff, right, is optional. All these other commands, language capabilities, software, boot software version ID, DMX personality and description, sensors, and so on. All of that is optional, but like it has to be able to be discovered. It's required to identify itself, and it's required to tell the controller its name, its software version, and any additional parameters it supports. That's what the spec says you have to do, and everything else is just gravy for the user. How much of that will our little PocketRDM device actually follow through with? That's what a good question. All right, speaking of, we discover, so we turn the thing on. First thing we have to do is discover options, right? And now we're in our menu, we can address, we can config. If we go into discover, we can either rediscover everything, or once we found them, we can go back to our menu. And if we go into address, we can see we're selecting device 1, we can go back to our menu, right? So very, very, very basic, very basic UI for now, but we have a basic menuing system. We have sort of 3 different modes. We can enter into them. This, in theory, device 1 would be flashing. And if we pressed enter, we would go in and set the address for the device locally. And when we confirmed it, we would send the RDM message to address that device and so on. So there's quite a bit more state we'd have to track in some of these modes. But for, a solid evening's work, for a thing that's going in a plastic box, I'm actually really quite happy with how this UI is shaping up. Considering we spent the first 2.5 hours not working on it, this is the product of 90 minutes of work, and I feel great about that. And I feel great about hanging out with y'all this evening and getting your input in your device. So things that have to happen next on this project, right? The battery question, right? What do we do about batteries? I want to learn more about these little what do we call them? 4020 40 lipos that we found earlier in the evening. I think those have some real possibility. I want to understand more about how they charge. Could we get away with an internal, what if we were to put them on an internal charger, what would it need to be? And if it's more than just constant voltage, it's going to be a little bit of a challenge. I mean, it's all going to be a little bit of a challenge. Is it an internal battery? Is it something you have to swap out externally? Did we ever settle on whether AAAs? So a single AAA does fit in here pretty nicely, actually. Or coin cells, maybe two coin cells in parallel was an option that we had. I don't know if you can get double coin cell holders, which might be kind of nice. I also don't know that a 2032 will fit in here. Did we try that? Oh, maybe we did. Here we go. You see how I was kind of wrapping up, and then just completely. So that actually fits in there quite nicely. So if two of those, if a cheapy coin cell holder, and what I'm thinking of is something like a PCB mount 2032 coin cell holder. Here we go. Number of cells. Oh, interesting. You can get 1 and 2 cell holders. Let's get our 20mm coin cell holder options up here. Yeah, like something that, you know, is battery clips on the back of a PCB. If there were 2 coin cells on the sort of the bottom of the PCB, so to speak, that feels like a plausible option, right? Because we got, you know, 20 hours of runtime-ish, and I was fudging the math there pretty hard, and Thomas pointed out working at the wrong voltage. You know, a year of standby time on coin cells is not awful. Rechargeable would obviously be best. There's also, I'll be totally candid, as I've said, you know, a couple times this evening, I'm not an engineer, and I'm just doing this because I think it's interesting and fun. There's also, I think, a version where like the, you know, the alpha version is coin cells or, you know, AAAs or something, you know, kind of boring like that, and a future version when I decide I want to learn, you know, battery technologies a little bit better, then it moves to LiPos, right? Kind of like with the moving lights project. It's like, okay, well, this iteration is about learning about, you know, PCB assembly services, and so I'm not going to press forward the technology for the, you know, heatsink. Okay, the assembly service I've got unlocked, so now I have to think about, you know, programmability and pogo pins. All right, now I'm going to do a version that's just focused on like how do we get the bootloader onto the thing and so on. So, you know, I think there may be a few iterations of how that battery technology goes, but it's neat that there are a couple potential options. It feels like out there, maybe, and yeah, I'm not entirely sure which one I want to start with, but I've got lots of cool ideas. Thanks to this fun evening, and thanks to y'all. Thank you, all of y'all, for being here tonight. Those who are here, those who are. Have left us earlier in the evening but are watching this back later. I know that's a couple people's MO is like it's to drift off to sleep to the melodious pipes, and I totally get that. I've certainly done the same thing, not on my own stream, hopefully, although who knows. Yeah, thanks everybody. Fun Sunday night. I'll be back again next Sunday night. I'm not sure what exactly we'll be doing. It might be more Demilight stuff. It might be more like Arduino and Raspberry Pi class-based stuff. That's sort of the other half of the things that I do. Either way, if you subscribe and hit that bell, I just can't say it with a straight face. Then you'll know when the things come up, and you can decide for yourself if it's something you want to, you know, watch all 4 hours of. Although it probably won't be another 4 hours again. But yeah, you can pop back in, or at least just come and say hi. It's good to see all of your fun names and all your fun things saying hi. Thanks, Broke Both. Yeah, it's a cool project. I'm excited to keep chugging away on it. There's certainly some stuff I need to learn for it, which is part of the joy of it. Coming up down the road, like things that are in the future for this channel and for videos and for streams. At some point, I might do a workshop tour when the new 3D printer should ship in about a week and be here a week after that. Once that's in and the new monitor mounts and the enclosure are in, this place will be in pretty decent shape. So I might do a workshop tour, just because it's kind of a fun thing to do. More mini moving light stuff. Once the Prusa is in, we'll be like just chugging out mini moving light parts. That'll be fun, as well as some like D&D related parts, which I think will be fun for myself and for our Dungeon Master, who is a wonderful person and deserves the world. And we'll just keep making cool things and learning stuff together. Ooh, yes. Yeah, Thomas, Thomas is a cool person to find. He's also working on tiny moving lights, a little bit bigger, a little bit more precise than mine. Super cool. I'm excited to see where he goes. Cookie, if you make progress on or have progress already on your chain motor, please stop by and let us know, or tweet at me. If you have questions or you like this project, you're like, hey, this thing you did, I'm trying to work on too. What did you mean? Fastest way to get me is at Jeffers on Twitter. You can also always call me on the bat phone, which apparently rings at more hours of the day than I thought, so call anytime. 815-0-MALORT. Information about this project is at jeff.glass/Demilight. Build your own at jeff.glass/Demilight/build. Please be safe. Please wash your hands. Please wear a mask. We're in the home stretch of this thing. It might be a bit of a seventh inning stretch instead of a home stretch, but we got this. Stay safe. Hydrate. Get some sleep if you can. And I will see you next week. Have a good night, everybody.